Space is trying to kill you. That's not hyperbole or dramatic effect. It's the cold, hard truth of cosmic reality. In the vastness beyond our thin bubble of atmosphere, in that midnight void that beckons with stars and possibilities, everything, absolutely everything, is engineered for your extinction. You believe we're ready to live among the stars? That Mars colonies and lunar habitats are just engineering challenges waiting to be solved? That humanity's cosmic destiny awaits with just enough ingenuity and willpower? The universe disagrees. The Big Bang did not bang. There was no sound, no explosion as we understand it, because sound cannot travel through the vacuum. From the very beginning, the cosmos established its first lethal rule. Silence is the natural state of existence. Your voice, your breathing, your heartbeat, these sounds define your living experience, yet they are anomalies in the grand scheme of reality. To step beyond Earth is to confront a universe where your most basic human experiences become impossible. But that's just the beginning of the contradiction. You evolved under precise conditions, a specific gravity well that shaped every bone, every muscle, every circulatory pathway in your body. The pressure of our atmosphere, the exact composition of our air, the magnetic shield that deflects cosmic radiation, the exact distance from our star that permits liquid water. Your entire biological existence is calibrated to function in this one specific environment, on this one pale blue dot. What happens when you leave it? Your body begins to betray you. In zero gravity, your bones leach calcium, weakening at a rate of 1 to 2% per month. Your muscles atrophy. Your heart, no longer fighting Earth's pull to pump blood upward, begins to weaken and reshape itself. Your eyes change shape, affecting your vision. Cosmic radiation, the silent, invisible storm of high-energy particles streaming through space, bombards your DNA, increasing cancer risk and potentially altering your cognitive function. Your very cells recognize the wrongness of space. Ask yourself, if your body so violently rejects the cosmos, were we ever meant to live there at all? The Earth took 4.5 billion years to configure itself into a habitable world for complex life. 4.5 billion years of volcanic eruptions, asteroid impacts, atmospheric transformations, the slow dance of plate tectonics, the emergence of life that gradually transformed a poisonous atmosphere into breathable air. This wasn't intelligent design, it was incomprehensible luck played out over geological timescales. And you think we can replicate this miracle on Mars in a few decades? Mars, the planet whose thin atmosphere was stripped away by solar winds, whose water retreated underground or escaped into space, whose core cooled and magnetic field died, leaving its surface bombarded by radiation. The red planet is not simply awaiting human inhabitants, it actively resists them. Its dust storms can last for months. Its soil is permeated with toxic perchlorates. Its average temperature hovers around 80 degrees. Every single day on Mars would require technological intervention just to maintain the basic necessities of human survival. If you could stand on Mars without a spacesuit, your blood would begin to boil in about 90 seconds. Your final conscious moments would be excruciating agony as the moisture on your tongue, in your eyes, in your lungs, flash vaporized. The universe's verdict would be swift and certain. You do not belong here. This is the impossible challenge. Yet, here we are, reaching outward, sending fragile human bodies wrapped in technological cocoons to orbit our planet, building plans for lunar bases, for Martian colonies, for habitats spinning to create artificial gravity. We design life support systems, radiation shields, closed-loop ecosystems. We dream of terraforming, of transforming alien worlds to suit human needs over centuries or millennia. Is this humanity's greatest conceit or our greatest strength? The audacity to believe we can overcome 4.5 billion years of evolutionary programming and establish ourselves where nothing in our biology prepared us to exist? If you could rewind time to the primordial Earth, to the Hadean Eon, when our planet was a hellscape of molten rock, volcanic upheaval, and toxic atmosphere, would you look at that world and believe it could someday support complex life? That creatures would eventually emerge who could contemplate the stars and yearn to reach them? The transformation seems impossible, yet here we are, now fast forward. Imagine Mars or Venus or the moons of Jupiter, barren, hostile, alien, transformed over centuries by human intervention into habitable worlds. Is this any more impossible than Earth's own transformation? Or have we simply replaced geological timescales with technological ones? Natural selection with conscious design? The cosmic contradiction deepens when we consider our organic complexity. You are a being of extraordinary fragility. Your consciousness, that ephemeral phenomenon that allows you to contemplate these words right now, exists because of the precise arrangement of approximately 86 billion neurons in your brain, consuming 20% of your body's oxygen, maintained at an exact temperature and biochemical balance. Disrupt this balance for mere minutes, and you cease to exist as a thinking entity. Yet this same consciousness has conceived of multi-generation ships traveling between stars, of suspended animation, of digital consciousness uploaded into machines, of transforming human biology itself to adapt to alien environments rather than transforming those environments to suit us. Where does biological reality end and science fiction begin? What are the ethical boundaries of reshaping human biology? To survive in space? If we engineer humans to withstand radiation, to process different atmospheric compositions, to function in different gravity wells, at what point do we become something other than human? Is that transformation a betrayal of our nature, or its ultimate expression? The stars continue their silent vigil, indifferent to our existential dilemmas. Consider the vast energies involved in space travel. To escape Earth's gravity, well requires accelerating to 11.2 kilometers per second, the equivalent of releasing the energy of TNT equal to your body weight. The Saturn V rocket that carried humans to the moon stood 363 feet tall and weighed 6.2 million pounds to deliver a lunar module weighing just 32,399 pounds. The inefficiency is staggering, like building a jumbo jet to transport a single passenger. And that was just to reach our nearest celestial neighbor. The distances beyond the moon become nearly incomprehensible. Mars, at its closest approach, lies 34 million miles away, a journey of months even with our most advanced propulsion. The nearest star system, Alpha Centauri, sits 437 light-years distant, over 25 trillion miles. At the speed of Voyager 1, our fastest outbound spacecraft, it would take approximately 73,000 years to arrive. Multiple generations would live and die in transit, never knowing either Earth or their destination, existing solely as links in a chain of cosmic migration. The physics of space travel reveals another contradiction. The faster we want to go, the more fuel we need. The more fuel we carry, the heavier our spacecraft becomes. The heavier our spacecraft, the more fuel we need to accelerate it. This is the tyranny of the rocket equation, a mathematical reality that constrains our cosmic ambitions as surely as biology constrains our physical forms. Yet even as we acknowledge these brutal realities, humans continue to dream, to design, to push boundaries. We develop ion engines, solar sails, nuclear propulsion concepts. We consider space elevators, launch loops, fusion rockets. Each technological advancement doesn't solve the impossible challenge. It merely transforms it, reshapes it, pushes it further into the future. Is this persistence admirable or delusional? Your existence on Earth required no technological intervention. You breathe without conscious effort. Your body regulates its temperature, repairs itself, extracts oxygen from the atmosphere automatically. Water falls from the sky. Plants convert sunlight to food. Ecosystems cycle nutrients. The complexity of these systems developed over billions of years of evolution, perfect synchronicity between organism and environment. In space, every one of these automatic processes must be replaced by technology. Every breath, every drop of water, every calorie of food, every waste product must be accounted for, recycled, managed. The complexity is overwhelming. The International Space Station, our most sophisticated off-world habitat, requires constant resupply from Earth, constant maintenance, constant monitoring. It exists 250 miles above our planet, practically a stone's throw in cosmic terms. Yet, maintaining human life there consumes enormous resources, scale that challenge to Mars. To TTZ, the outer planets. To interstellar space. Now expand the timescale from days to decades, to centuries, to the multi-generational timeframes that meaningful space colonization would require. The technological systems supporting human life would need to function with remarkable reliability. On Earth, when technology fails, the environment remains habitable. In space, technological failure means extinction. There is no margin for error, no natural safety net, no ecosystem to fall back on. The psychological weight of this reality on space colonists would be immense. Living perpetually on the edge of annihilation, saved only by machines of human creation. And what of the human mind in these environments? You evolved in open spaces, under blue skies, surrounded by living things, by diversity, by sensory richness. What happens to human psychology in the confines of a space habitat? In environments where every square foot must be engineered and maintained at tremendous cost? Where there are no horizons, no weather, no spontaneous natural beauty? Studies of isolated environments on Earth, Antarctic research stations, submarine crews, isolated military outposts, reveal the psychological strain of confined living. Depression, anxiety, conflict, cognitive decline. And these environments at least exist under Earth's gravity, with the knowledge that the natural world exists just outside. What awaits the human mind in the sterile corridors of a Mars habitat, millions of miles from Earth, with no possibility of return? Perhaps we underestimate human adaptability. Perhaps we will develop new forms of art, new cultural expressions, new psychological frameworks for finding meaning in engineered environments. Perhaps humans born on Mars or orbital habitats would find Earth's open spaces overwhelming, its gravity oppressive, its teeming biodiversity disturbing. What would it mean to be human without Earth? To never feel rain on your skin or wind in your hair? To never wade into an ocean or climb a mountain or watch a sunset through an atmosphere? To exist in a world where every element of your environment was designed by other humans? The question becomes philosophical as much as technological. What is the essence of humanity? Is it our biology, our planet of origin, our relationship with nature? Or is it something more portable, our consciousness, our creativity, our capacity for adaptation and meaning-making? If humans born off-world develop their own cultures, their own adaptations, their own relationships with their engineered environments, will they still be human as we understand the term? Or will they become something new? Post-Earth humans, the first true aliens of our lineage. Consider the long arc of evolution. Life began in the seas, then colonized land, developing new biological systems to cope with the radically different environment. The transition from water to land might have seemed impossible to fish. Yet, here we stand, descendants of creatures who made that impossible journey. Is the transition from Earth to space simply the next great evolutionary leap? But there's a crucial difference. The transition from sea to land occurred over millions of years through countless small adaptations, each providing an evolutionary advantage. The transition to space occurs on technological timescales, decades, not millennia. There is no time for natural selection to work its gradual magic. We must engineer solutions to problems that evolution would take eons to solve. This is perhaps the ultimate contradiction of space colonization. We attempt to shortcut evolutionary timescales through technological means. Can technology truly replace or accelerate processes that took billions of years to unfold naturally? The vacuum of space offers no quarter. In the shadow of a lunar crater, temperatures plunge to 280 degrees. In direct solar exposure, they soar to 260 degrees. This thermal extremity is another reminder of Earth's perfect calibration for our existence. Our planet's atmosphere moderates temperatures, preventing the wild swings that characterize airless worlds. On Earth, we take for granted the protection of our magnetosphere, the magnetic bubble generated by our planet's molten core that deflects the solar wind and cosmic radiation. Without it, charged particles would strip away our atmosphere and bombard the surface, as happened to Mars billions of years ago. Any permanent human presence on Mars, the Moon, or in deep space must recreate this protection or suffer the consequences of increased radiation exposure, cancer, cellular damage, cognitive impairment. Then there's gravity, or rather, its absence. The human body in zero gravity undergoes profound changes. Without the constant pull of Earth's gravity, bones lose density at an alarming rate. Muscles atrophy. The heart, no longer working against gravity to pump blood upward to the brain, weakens. Fluids redistribute throughout the body, causing the face to puff and potentially increasing pressure on the eyes and brain. The spine elongates as vertebrae decompress, sometimes causing pain and affecting nervous system function. These aren't merely inconveniences, they're fundamental biological responses indicating that the human body is operating outside its designed parameters. After millions of years of evolution under Earth's 1G environment, our biology rejects the absence of gravity, like an immune system rejects a foreign body. On Mars, with roughly 38% of Earth's gravity, these problems would be less severe, but still significant. Would children born on Mars develop normally? Would their bones and muscles form correctly in reduced gravity? Would their circulatory systems function properly? We simply don't know. We have no data on mammalian development in partial gravity environments. These questions become even more complex when we consider reproduction in space. Studies on Earth suggest that microgravity disrupts fundamental cellular processes involved in conception and embryonic development. Without the orienting force of gravity, cellular division may occur abnormally. The intricate dance of development that transforms a single fertilized cell into a complex organism depends on gradient forces, molecular signaling, and physical processes that evolved under Earth's gravitational influence. Could humans truly establish self-sustaining colonies if we cannot reproduce successfully off-world? Is technological intervention in human reproduction, artificial wombs, genetic engineering, an acceptable solution? Or does the very need for such intervention suggest that we are attempting something fundamentally unnatural? When the first astronauts left Earth's atmosphere, they reported a phenomenon that would come to be called the overview effect, a profound cognitive shift in awareness upon seeing Earth from space. The planet appears as a fragile blue marble suspended in darkness, with no visible borders or divisions, protected only by a paper-thin atmosphere. Many astronauts report a deep sense of the interconnectedness of all life, and a new understanding of Earth as a single, precious ecosystem. Ironically, it took leaving Earth for humans to truly appreciate it, to recognize its uniqueness, its perfection, its irreplaceability. As we contemplate establishing human presence throughout the solar system, we must ask, are we abandoning our home or expanding our understanding of it? Are we rejecting Earth or carrying its essence with us into the cosmos? The technological challenges of space colonization, life support systems, radiation protection, artificial gravity, closed-loop ecosystems all aim to recreate aspects of Earth's environment that we depend on. In essence, we are not leaving Earth behind so much as attempting to carry miniature versions of it with us, encapsulated in technological bubbles. Is this the future of humanity? To exist in artificial Earths scattered throughout the solar system and beyond? To never again experience the natural world as our ancestors did, but instead to live in engineered approximations designed to sustain our Earth-evolved biology? Perhaps the most profound question is not whether we can overcome the physical and technological challenges of living beyond Earth. Human ingenuity has overcome seemingly insurmountable obstacles before, but whether we should. What is gained and lost in this transition? What aspects of human experience, of our relationship with the natural world, of our sense of place and belonging, might be sacrificed in the journey to the stars? As we contemplate the impossible challenge of living beyond Earth, we must acknowledge the deep contradiction at its heart. Everything that makes us human evolved in one specific environment on one specific planet. Yet we dream of existing beyond it. We are Earth creatures contemplating un-Earth existence. This contradiction isn't merely technical, it's existential. It forces us to question what it means to be human, what elements of our existence are essential versus incidental, what aspects of Earth we must carry with us, and what we can leave behind. The cosmos presents us with environments that actively resist human life. Every moment of existence beyond Earth requires technological intervention, a perpetual act of defiance against the natural state of the universe. Is this sustainable? Can we maintain the complex technological systems required for off-world survival indefinitely, across generations, across centuries? History on Earth suggests that civilizations rise and fall. Technologies advance and are sometimes lost. Knowledge is gained and forgotten. The Roman aqueducts crumbled as their civilization declined. The precise techniques used to build the pyramids were lost to time. What happens to a Mars colony if supply chains from Earth are disrupted? If political will wanes? If economic systems collapse? The margin for error in space is non-existent. Technological regression that might cause hardship on Earth would mean extinction off-world. Yet for all these challenges, these contradictions, these seemingly insurmountable obstacles, humanity continues to reach outward. Is this merely human hubris, the refusal to accept our biological limitations? Or is it something more profound, the expression of a uniquely human capacity to transcend our origins? Consider the Wright brothers at Kitty Hawk in 1903. Their first powered flight lasted 12 seconds and covered 120 feet. The idea of crossing oceans by air of routinely traveling at hundreds of miles per hour above the clouds would have seemed absurd, impossible. Yet within a human lifetime, commercial aviation had transformed global transportation. The impossible became mundane. Is space colonization simply the next frontier of the seemingly impossible? Will future generations look back at our concerns the way we view early concerns about train travel, with amusement at how limited our vision was? Or is there a fundamental difference? Flight may have been unnatural for humans, but birds had mastered it for millions of years. Aviation didn't violate physical laws, it worked within them. Space colonization asks us to exist in environments where no comparable life has ever survived, where the physical laws themselves seem arrayed against biological existence as we understand it. The night sky above you contains roughly 5,000 stars visible to the naked eye. With binoculars, that number jumps to about 200,000. With a modest telescope, millions. Each point of light represents a sun, many larger than our own, many with their own planetary systems. The sheer scale staggers the imagination. Yet for all that immensity, we have found no evidence of life beyond Earth, let alone complex, intelligent life. The Fermi paradox haunts our cosmic ambitions. If the universe is so vast and so old, where is everybody? Why has no civilization emerged to master interstellar travel, to colonize the galaxy, to make its presence known? Perhaps the answer lies in the very challenges we're contemplating. Perhaps the leap from planetary to interplanetary civilization is simply too great, a filter that few, if any, species ever pass. The physics, the biology, the technology, the sustainability. Perhaps these challenges have silenced countless civilizations before they could announce themselves to the cosmos. Or perhaps we are among the first to try. Perhaps the universe is young, in cosmic terms, and we stand at the dawn of a great migration that will eventually populate the stars with our descendants or post-human successors. The silence of the universe offers no guidance. We face the impossible challenge alone, armed only with human ingenuity, curiosity, and determination. As you contemplate these ideas, remember that your contemplation itself, the firing of neurons in your brain, the emotional responses in your body, the very fact of your conscious awareness, depends entirely on biological systems that evolved specifically for Earth. The carbon atoms in your cells, the oxygen you breathe, the water that comprises most of your body, all these elements were forged in dying stars billions of years ago, collected into our solar system, and organized over eons into the precise conditions that permit your existence. You are, in the most literal sense, a child of Earth, made from its elements, shaped by its environment, dependent on its systems. To leave it is to leave the womb that sustained our species from its earliest moments. The impossible challenge of living beyond Earth is not just technological, it's biological, psychological, philosophical, spiritual. Yet the same cosmic origin that binds us to Earth also connects us to the stars. The elements in your body were indeed forged in stellar furnaces. In a very real sense, we are the universe becoming conscious of itself. The cosmos evolved to contemplate its own existence. Perhaps our drive to expand beyond Earth is simply the next step in this cosmic evolution. The universe using the mechanism of human consciousness and technology to spread awareness of itself more widely. If we succeed in establishing self-sustaining human presence beyond Earth, it will represent not just a triumph of technology, but a fundamental transformation in what it means to be human. Earth humans will become universe humans, carrying the legacy of our home planet into environments never meant to support us, creating new relationships with new worlds. this transformation will not come easily. The universe will resist at every step. Physics, biology, psychology, economics, all will present obstacles that seem insurmountable. Many attempts will fail, lives will be lost, resources will be expended that might have improved conditions on Earth. The ethical calculations are complex and without clear answers. Yet, throughout human history, we have defined ourselves not by our limitations, but by our ability to overcome them. We left the trees for the savanna, crossed oceans in fragile vessels, conquered disease, extended lifespans, developed global communication networks, split the atom, unraveled DNA. Each step seemed impossible until it was accomplished. The impossible challenge of living beyond Earth may be the greatest we have ever faced. It contradicts our biology, defies our evolutionary programming, requires technological systems of unprecedented complexity and reliability. The vacuum waits silently to kill us. Radiation seeks to damage our very DNA. Alien regolith resists our agriculture. Isolation threatens our mental health. Distance strains our supply chains and communication networks. And yet, we persist. We design. We build. We launch. We dream. Is this the destiny of consciousness in the universe? To emerge through evolution on planets like Earth, develop technology, and then spread outward, carrying the seeds of awareness to worlds that would otherwise remain unconscious? Is humanity, with all its flaws, its brilliance, its contradictions, the mechanism by which the cosmos achieves greater self-knowledge? Or are we simply refusing to accept our place, our limitations, our brief moment on one small world in an indifferent universe? The answer may not be purely technical. It may not be found in better rockets, more efficient life support systems, more reliable artificial gravity. It may lie in how we define progress, purpose, and the meaning of human existence, in how we balance individual lives against species survival, in how we weigh present suffering against future possibilities. As you consider the impossible challenge of living beyond Earth, ask yourself, what does it mean to be human without Earth? What is gained and lost in this transition? What carries forward, and what must be left behind? The stars continue their silent testimony, indifferent to our questions, our struggles, our ambitions. They have witnessed the rise and fall of countless species over billions of years. They will shine long after our sun has expanded and consumed the inner planets of our solar system, including Earth. In cosmic timescales, even our home is temporary. Perhaps this is the ultimate reason why we look to the stars, not because Earth is insufficient, but because its sufficiency is finite. In the longest view, Earth itself is not permanent. If consciousness is to survive in the universe, if the cosmos is to remain aware of itself, then life must eventually find homes beyond its birthplace. The impossible challenge of living beyond. Earth may be exactly that. Impossible in any meaningful time frame with any technology we can currently imagine. Or it may simply be the next great barrier for human ingenuity to overcome. Like flight, like disease, like instantaneous global communication once seemed. Either way, the attempt itself, the reaching outward, the willingness to confront our limitations and try to transcend them, speaks to something profound about human consciousness. We are creatures of paradox, evolutionary products of Earth who dream of the stars, biological entities imagining post-biological futures, mortal beings contemplating immortal legacies. The universe does not care whether we succeed or fail in this ambition. The laws of physics will not bend to accommodate our desires. The vacuum will not become less lethal. radiation less damaging, distances less vast because we wish it so. The challenge remains impossible until we make it possible, through technology, through adaptation, through reimagining what human civilization can be. As we stand at this crossroads, a species capable of contemplating its expansion beyond its birth world, but not yet capable of achieving it sustainably, we must ask not just whether we can live beyond Earth, but what kind of existence that would be. What values, what aspects of humanity are essential to carry forward? What new forms of human experience might emerge in these alien environments? What will it mean to be human when Earth is a distant memory, or merely one world among many that humans inhabit? The impossible challenge awaits. The stars watch in silence. And humanity, as it has always done, steps forward into the unknown, driven by curiosity, by necessity, by the simple, profound desire to see what lies beyond the next horizon. We all know how the universe began. A singular point of infinite density, a cosmic egg containing all matter, all energy, all potential. Then, in a fraction of a second, too small for human comprehension, it expanded. The Big Bang, that comfortable creation myth of modern science, that gives us a definite beginning, a cosmic birthday for reality itself. But what if this most fundamental truth of our cosmic origin is merely a convenient fiction? The early universe wasn't just hot. It was a furnace where time itself was still learning to move. Our mathematics breaks down completely in those first moments. The laws of physics, as we understand them, simply did not exist. What we call the beginning might not have been a beginning at all, but a transition, a phase change in a reality that extends backward in directions our minds cannot follow. Picture a two-dimensional being living on the surface of a balloon. As the balloon inflates, every point moves away from every other point. From the perspective of this flat creature, the universe is expanding in all directions, with no discernible center. The creature might naturally ask, where did the expansion begin? Where is the center? But the question itself is meaningless. There is no center on the surface of a sphere. The expansion happens everywhere at once. Our three-dimensional universe works the same way, but with an additional spatial dimension. The Big Bang didn't happen at a point in space. It happened everywhere simultaneously. There was no outside for it to expand into, no pre-existing void to fill. Space itself was created in that moment, unfurling like a flower with infinite petals. If the universe has no edge, then where does it begin? If the Big Bang happened everywhere at once, then where exactly did it happen? The contradiction lurks in our very language, in the limitations of minds evolved to track predators on African savannas, not to contemplate the birth of space and time. Consider the cosmic microwave background radiation, the afterglow of the Big Bang that permeates the universe in all directions. This omnipresent whisper, just 2.7 degrees above absolute zero, is our most direct evidence of the universe's fiery birth. But there's something profoundly unsettling about this radiation. It's too uniform. Regions of space on opposite sides of our observable universe have the same temperature, down to tiny fractions of a degree. Yet these regions are so far apart that, given the age of the universe and the speed of light, they could never have communicated with each other. How did they reach the same temperature if they never touched? This is the horizon problem, and it suggests something bizarre about cosmic history. Either information traveled faster than light in the early universe, or our understanding of cosmic origins is fundamentally incomplete. To resolve this contradiction, physicists proposed cosmic inflation, a period of exponential expansion in the first trillionth of a trillionth of a trillionth of a second after the Big Bang, when the universe expanded faster than light itself. Not by breaking the cosmic speed limit, but by stretching the very fabric of space-time. During this inflationary epoch, a region smaller than a proton expanded to the size of a grapefruit almost instantaneously, smoothing out temperature differences and setting the stage for the more leisurely expansion that followed. But inflation creates its own contradictions. What triggered it? What stopped it? And if it happened once, could it happen again? Some theories suggest our entire observable universe might be just one bubble in a vast multiverse, each bubble with its own physical laws, its own constants, its own version of reality. What we call the laws of nature might be mere local ordinances, provincial rules that apply only in our cosmic neighborhood. Imagine the implications for space colonization if true. We might someday reach the edge of our bubble, the boundary where our physics gives way to something else. Would our technology still function? Would our biology still cohere? Or would we find ourselves tragically incompatible with a universe operating under different rules? The cosmic stage upon which we play out our dreams of space colonization is stranger than we can comprehend. And this strangeness extends to the most fundamental aspect of reality: matter itself. You believe you understand what matter is, the solid stuff of reality, the atoms and molecules that make up your body, your spacecraft, the planets you hope to colonize. But peer closer, and matter dissolves into probability clouds, into waves of possibility, into patterns of information in quantum fields. The atom, once thought to be the indivisible building block of nature, revealed itself to be mostly empty space. A hydrogen atom is 99.9999996% void. If its nucleus were the size of a pea, its electron would orbit a kilometer away. You, solid as you seem, are a ghost made of mathematical patterns in quantum fields, held together by forces we can describe, but not truly explain. And those forces, gravity, electromagnetism, the strong and weak nuclear forces, present their own cosmic puzzle. Why these four? Why these specific strengths? Change the gravitational constant by a fraction, and stars cannot form. Adjust the strong nuclear force slightly, and complex atoms become impossible. Tweak the electromagnetic force, and chemistry itself breaks down. The precise calibration of these cosmic forces seems almost deliberately tuned for complexity, for the emergence of stars, planets, and ultimately life. This is the anthropic principle, the observation that the universe appears fine-tuned for our existence. But this apparent design creates a profound contradiction. In a random universe, why would physical constants happen to take on exactly the values needed for complexity? Are we incredibly lucky? Are we living in a selected universe from a vast multiverse ensemble, where most bubbles remain sterile and lifeless? Or is there some deeper principle at work that necessitates these values? The stage of our cosmic drama grows curiouser still when we consider dark matter and dark energy, the invisible actors that make up 95% of our universe's content. Dark matter holds galaxies together, forming the scaffolding of cosmic structure. Yet we cannot see it or touch it. It passes through ordinary matter like a ghost, interacting only through gravity. Dark energy drives the accelerating expansion of the universe, pushing galaxies apart at an ever-increasing rate. Yet we have no idea what it is, only that it comprises roughly 68% of everything that exists. Think about that. Nearly 95% of our universe consists of substances we cannot see, cannot touch, and barely understand. We're like blind sailors navigating by the effects of invisible currents, trying to map an ocean whose true nature remains hidden. and we dream of colonizing this ocean, of mastering it, when we've barely begun to comprehend its basic properties. Let's zoom in from the cosmic to the galactic. Our Milky Way, that great spiral of stars that appears as a luminous band across our night sky, contains between 100 and 400 billion stars. If you could count one star per second, it would take you over 12,000 years to count them all. Around most of these stars orbit planets, trillions of worlds, each unique, each with its own history, its own chemical composition, its own potential. Yet for all this abundance, we have found no clear signs of other technological civilizations. No radio signals, no megastructures, no evidence of interstellar travel or engineering projects visible to our telescopes. The galaxy appears hauntingly empty of the technological signatures we might expect from spacefaring civilizations. This emptiness, this great silence, presents another cosmic contradiction. Given the age of the universe and the billions of potentially habitable planets that have existed for billions of years, where is everybody? Even if intelligent life is rare, even if technological civilization emerges on only 1 in a billion suitable planets, there should still be thousands of spacefaring civilizations in our galaxy alone. Yet we see none. Perhaps the challenge of living beyond a home planet is even greater than we imagine. Perhaps the leap from planetary to interstellar. Civilization represents a filter that few, if any, species ever cross. The physics, the biology, the sustainability. Perhaps these challenges have silenced countless civilizations before they could announce themselves to the cosmos. Or perhaps we are alone, a cosmic accident, a statistical fluke, the only technological species to emerge in our galaxy. This possibility is perhaps the most disturbing of all. It would mean that the responsibility for bringing consciousness to the stars falls solely on our shoulders. It would mean that if we fail in the impossible challenge of living beyond Earth, consciousness itself might remain forever trapped on this pale blue dot, destined to expire when our sun eventually dies. As we set the stage for humanity's greatest adventure, we must confront another cosmic reality: the tyranny of distance. Space is big. You just won't believe how vastly, hugely, mind-bogglingly big it is. The distances involved in space exploration stretch not just our technology, but our psychology, our ability to conceptualize scale beyond human experience. Consider our solar system. Light from the Sun takes 8 minutes to reach Earth. To Neptune, it takes over 4 hours. Voyager 1, launched in 1977, has traveled farther than any human-made object. Yet after more than 45 years of continuous flight, at speeds exceeding 38,000 miles per hour, it has barely left our solar system's doorstep. The nearest star system to ours, Alpha Centauri, lies 437 light-years away, approximately 25 trillion miles. Our fastest spacecraft would take tens of thousands of years to reach it. Even light, the cosmic speed limit, takes years to cross these interstellar gulfs. The contradiction here is that space is simultaneously too vast for human timescales, yet too confined for truly isolated experimentation. A failed colony cannot truly try again without interference. The stage is too small for genuinely independent attempts, yet too large for easy communication and support. These distances create profound challenges for space colonization. Even within our solar system, communication delays become significant. A message to Mars takes between 4 and 24 minutes to arrive, depending on orbital positions. A conversation with a lunar colony would have a minimum 5-second delay between question and answer. To Jupiter's moons, the delay stretches to over an hour round trip. These delays may seem manageable, but they fundamentally alter the nature of human interaction. No real-time conversation, no immediate response to emergencies, no instantaneous sharing of experiences. Colonies throughout the solar system would be connected only by the thin, delayed thread of electromagnetic communication, gradually diverging in culture, in language, in values, simply because of the tyranny of light speed. Beyond our solar system, these challenges become insurmountable with current physics. Any interstellar colony would be effectively isolated from Earth, developing independently with no possibility of timely guidance or intervention. Humanity would splinter into separate evolutionary and cultural paths, perhaps eventually becoming different species altogether. Is this divergence the cosmic destiny of intelligence? To spread outward from its point of origin, diversifying into 1,000 forms, 1,000 cultures, 1,000 experiments in consciousness? Or does it represent a failure of unity, a cosmic diaspora that dilutes rather than enhances the promise of intelligence in the universe? The stage upon which we hope to enact our cosmic expansion is rendered even more complex by the nature of planets themselves. We evolved on a geologically active world, a planet whose interior remains hot enough to drive plate tectonics, to generate a protective magnetic field, to cycle elements between crust, mantle, and atmosphere. This geological engine has been crucial for Earth's long-term habitability, regulating atmospheric composition, recycling nutrients, and stabilizing global temperature over billions of years. Most worlds lack this geological vitality. Mars, once geologically active, cooled too quickly, losing its magnetic field and much of its atmosphere. Its volcanism ceased, its plate tectonics froze, its water retreated underground or escaped to space. Venus, perhaps once habitable, experienced a runaway greenhouse effect, its surface now hot enough to melt lead, its atmospheric pressure 90 times that of Earth. Mercury, airless and tidally locked, experiences temperature swings of over 100 degrees between day and night sides. The moons of gas giants offer tantalizing possibilities. Europa, with its subsurface ocean, Titan with its thick atmosphere and hydrocarbon lakes. Yet each presents unique challenges. Europa's ocean lies beneath miles of ice, bathed in Jupiter's intense radiation belts. Titan's surface temperature hovers around 290 degrees, with methane rain falling from orange skies onto mountains of rock-hard water ice. Each world in our solar system represents a unique set of constraints, a unique chemical and physical environment that would require specific technological adaptations for human habitation. There is no one-size-fits-all solution to space colonization. Each destination demands its own specialized approach, its own life support technologies, its own architectural designs. And beyond our solar system, exoplanet discoveries have revealed that planetary systems are wildly diverse. Hot Jupiters orbiting close to their stars, super-Earths with crushing gravity, mini-Neptunes with thick hydrogen atmospheres, rogue planets wandering between stars, frozen in permanent night. The variety staggers the imagination and complicates any universal strategy for space colonization. The cosmic stage is not static either. Stars evolve, planets change, orbits shift. The universe we observe today is just one frame in a cosmic film spanning billions of years. The habitable zone around our sun, that narrow band where liquid water can exist on a planetary surface, is gradually moving outward as the sun brightens over its lifetime. In about 1 billion years, Earth will become too hot for complex life. In 5 billion years, the sun will expand into a red giant, potentially engulfing the inner planets. On even longer timescales, stars die, Galaxies collide. The universe expands. In roughly 100 trillion years, star formation will cease as the raw materials become exhausted. In a quadrillion years, even the longest-lived red dwarf stars will flicker out. Eventually, even protons may decay, matter itself dissolving into radiation in an ever-expanding, ever-cooling cosmos. Against this backdrop of cosmic transience, what does space colonization really mean? Is it a temporary extension of human existence? A brief flowering of consciousness in an ultimately doomed universe? Or might advanced civilizations find ways to transcend even these cosmic lifetimes, perhaps by creating self-contained pocket universes, or by transforming themselves into forms that can survive in the cold, dark spaces between dying stars? The cosmic stage has one more crucial property we must consider: its indifference. The universe has no inherent morality, no cosmic justice, no special concern for conscious beings. It operates according to physical laws that care nothing for our survival or extinction. Stars explode, wiping out any life in nearby systems. Asteroids impact planets, potentially ending billions of years of evolution in an afternoon. Gamma-ray bursts sterilize entire regions of galaxies without warning. In this indifferent cosmos, any human presence beyond Earth exists solely because we create and maintain the conditions for it. There is no natural place for humans anywhere but Earth. Every habitat, every colony, every outpost would be an island of habitability in a vast ocean of lethality, maintained only through continuous technological intervention. This creates a fundamental contradiction in the dream of space colonization. We seek to expand human presence into a cosmos that is inherently hostile to that presence. We attempt to create persistence in an environment characterized by impermanence. We strive for safety in a universe defined by danger. Yet this very indifference also creates opportunity. With no cosmic script to follow, no predetermined role to play, humanity is free to write its own story in the stars. If we can overcome the immense physical challenges, the emptiness of space is both our greatest obstacle and our greatest canvas. Let's shift scale once more, from the cosmic to the human. The impossibility of living beyond Earth becomes more concrete when we consider the human body itself, that exquisite biological machine calibrated precisely for one specific environment. You evolved under a specific gravitational field, a specific atmospheric pressure, a specific radiation environment. Your bones developed to support your weight against Earth's pull. Your muscles grew strong enough, but not too strong, to move efficiently in our particular gravity well. Your circulatory system pumps blood upward to your brain against this same gravitational force. Your inner ear maintains your balance by referencing this constant downward acceleration. In microgravity, these systems begin to fail. Bones leach calcium, losing up to 1.5% of their mass per month. Muscles atrophy, including the heart, which shrinks as it no longer works against gravity. Fluids shift upward, causing puffy face syndrome and potential vision problems as pressure increases in the skull. The spine elongates as vertebrae decompress, sometimes causing pain and nerve issues. These aren't mere inconveniences. They're fundamental biological responses indicating that your body is operating outside its designed parameters. After millions of years of evolution on Earth, your biology simply isn't configured for space. Even more troubling are the effects we're only beginning to understand. Cosmic radiation damages DNA, potentially increasing cancer risk and affecting cognitive function. The psychological effects of isolation, confinement, and extreme environments can lead to depression, anxiety, and cognitive changes. The microbiome, the YB ecosystem of beneficial bacteria that lives in and on your body, may be disrupted by the sealed environments and altered immune function in space. The human body is not a singular entity, but a complex ecosystem that co-evolved with Earth's environment. Remove it from that environment, and the entire system begins to degrade. We can mitigate these effects through countermeasures, exercise, medication, radiation shielding, but we cannot eliminate them entirely without recreating Earth-like conditions or fundamentally altering human biology itself. This brings us to another cosmic contradiction. To truly live in space, we might need to become something other than human, as we currently understand the term. Gene editing to increase radiation resistance, artificial organs that function better in microgravity, neural interfaces to compensate for cognitive effects. The potential modifications are endless, but each step takes us further from our evolutionary heritage. Are we prepared for this transformation? For the ethical questions it raises? For the potential divergence of space-adapted humans from their terrestrial cousins? The cosmic stage doesn't just challenge our technology. It challenges our very definition of humanity. But perhaps the greatest challenge for space colonization isn't physical or biological, but ecological. Earth isn't just the planet that shaped your body. It's a vast, intricate system of interlocking cycles that maintain the conditions for complex life. The carbon cycle, the nitrogen cycle, the water cycle, the rock cycle. These planetary processes, operating over geological timescales, create the stable environment that permits our existence. Consider just one aspect: the oxygen in Earth's atmosphere. This didn't exist for much of our planet's history. It was created and is maintained by photosynthetic organisms, plants, algae, cyanobacteria, that convert carbon dioxide to oxygen. Without this biological machinery, oxygen levels would plummet as the reactive gas bonded with surface materials. Any space habitat, this entire planetary-scale process must be replicated through technology and carefully managed ecosystems. Every breath you take would depend on these systems functioning perfectly, continuously, without fail. The margin for error would be minimal. A significant failure in life support could lead to death in hours or minutes. Earth's biosphere is also enormously redundant and resilient. If one ecosystem collapses, others can compensate. If one species goes extinct, others often fill its ecological niche. This redundancy is the product of billions of years of evolution, an intricate web of relationships that we barely understand, let alone know how to replicate. Space habitats, by contrast, would need to be designed from first principles, with every relationship between organisms carefully planned and monitored. This represents a profound shift in humanity's relationship with life, from participants in natural ecosystems to designers and managers of artificial ones. The contradiction here is striking. To survive in space, we must recreate the very nature we're leaving behind. The most successful experiment in closed ecological systems to date, Biosphere 2, ended with oxygen levels dropping dangerously low, crops failing to produce sufficient food, and factional conflicts among the human participants. And this was on Earth, with the option to open the doors if things went catastrophically wrong. In space, there would be no such safety valve. This ecological challenge extends to resources as well. Earth provides abundant water, soil, minerals, and energy, the raw materials for civilization. In space, these resources must be extracted from asteroids, moons, or planets through energy-intensive processes, then carefully recycled within closed systems. Nothing can be wasted. Everything must be accounted for. The energy requirements alone are staggering. Earth receives abundant solar energy filtered through our atmosphere to power the entire biosphere. To recreate even a fraction of this energy flow in space requires vast solar arrays, nuclear reactors, or other power sources, all of which must be transported from Earth or manufactured in space from raw materials. The cosmic stage thus presents us with another contradiction. Space contains virtually limitless resources in absolute terms, yet accessing those resources requires enormous initial investment and involves tremendous practical difficulties. The universe is simultaneously one of scarcity and abundance, depending on your technological capabilities and time horizon. Space colonization enthusiasts often speak of the boundless resources of space, asteroids containing more precious metals than have ever been mined on Earth, unlimited solar energy unfiltered by atmosphere, vast regions for expansion. But this perspective ignores the tremendous difficulty of accessing these resources compared to their terrestrial counterparts. It's true that the asteroid belt contains enough raw materials to build habitats with thousands of times Earth's surface area, but transforming those raw materials into habitable environments requires energy, technology, and time on scales we've never attempted. The contradiction lies in the gap between theoretical abundance and practical accessibility, a gap that may narrow with advancing technology but can never be eliminated entirely. This brings us to perhaps the most profound contradiction in the E-key, cosmic setup, the Fermi paradox, which we touched on earlier. Given the age of the universe, the billions of stars in our galaxy, and the apparent ease with which life might evolve under the right conditions, where are all the other spacefaring civilizations? Why haven't they colonized the galaxy many times? Over in the billions of years the Milky Way has existed? The physicist Enrico Fermi summarized this contradiction in a simple question. Where is everybody? If space colonization is feasible, if intelligent life is not exceedingly rare, then at least some species should have spread throughout the galaxy long ago. Yet we observe no evidence of such expansion. This silence suggests several possibilities, none entirely comforting. Perhaps intelligent life is extraordinarily rare, a cosmic accident that has occurred only once in our galaxy. Perhaps technological civilizations invariably destroy themselves before achieving interstellar capability. Perhaps there exists some insurmountable barrier to space colonization that we have not yet encountered, a great filter that prevents virtually all species from expanding beyond their home planets. Or perhaps we are simply looking in the wrong places, asking the wrong questions. Perhaps advanced civilizations evolve beyond our ability to recognize them, transcending biological form, transforming themselves into something that doesn't register on our instruments or in our concepts. The Fermi paradox haunts our cosmic ambitions like a ghost, an absence that speaks volumes, a silence that raises questions we cannot yet answer. If we are the first technological species in our galaxy to attempt expansion beyond our home planet, the responsibility is both thrilling and terrifying. We would be pioneers not just for humanity, but potentially for conscious life itself in the Milky Way. But what if we're not the first? What if others have tried and failed, leaving no trace of their attempts? What if the cosmic stage contains hidden dangers we cannot yet perceive, challenges we cannot yet imagine? As we contemplate the physics of space travel, another contradiction emerges. The cosmic speed limit, the speed of light, creates a barrier that no material object can cross. This fundamental constant of nature limits how quickly we can travel between stars, how rapidly we can communicate across interstellar distances, how effectively we can coordinate any multi-system civilization. Even at the speed of light, a signal takes years to reach the nearest stars, decades to reach potentially habitable systems within 50 light-years, centuries to cross substantial portions of our galaxy. Any interstellar civilization would operate on timescales that challenge human psychology and social structures. Commands from a central authority would be hopelessly outdated by the time they arrived at distant colonies. Cultural exchange would occur over generational timescales. Unity would be difficult, if not impossible, to maintain. This limitation creates a scenario where any successful expansion into space would necessarily lead to divergence. Cultural, technological, perhaps eventually biological. Humanity would not expand as a unified entity, but would branch into numerous independent offshoots, each adapting to its local conditions, each developing in isolation from the others. Is this inevitable divergence something to embrace or resist? Does it represent the ultimate fulfillment of human potential? 1,000 different experiments in civilization, each testing different approaches to technology, society, and adaptation. Or does it represent a fracturing of human destiny? A cosmic diaspora that dilutes rather than enhances our collective future? The cosmic stage presents us with environments utterly alien to human experience. The vacuum of space, the radiation-bathed surfaces of airless worlds, the crushing pressures and exotic chemistries of gas-giant atmospheres, the sub-zero temperatures of the outer solar system. Each environment requires specific technological countermeasures, specific adaptations, specific architectures. In this alien context, what would home mean? Human psychology evolved in natural environments, under open skies, surrounded by living things, with the sensory richness of wind, weather, and wilderness. How would human minds adapt to the confined, engineered environments of space habitats? To the alien landscapes of other worlds? To the perpetual night of deep space? Some research suggests that humans require connection with nature for optimal psychological health, a concept called biophilia. Without access to natural environments, people may experience increased stress, cognitive fatigue, and mood disorders. Space habitats would need to incorporate elements of nature, plants, water features, natural light cycles, but these would be simulations, approximations, not the real wilderness that shaped our evolutionary psychology. This creates yet another contradiction. We bring elements of Earth with us not just for physical survival, but for psychological well-being. Yet these elements can never fully replicate the environment that shaped our minds and bodies. Space habitats would be simultaneously alien and familiar, neither fully Earth nor fully other. Children born in these environments would have no direct experience of Earth, no memories of open skies, of unengineered wilderness, of the sensory richness of a living planet. Their normal would be the confined technological environments of space habitats or the alien landscapes of other worlds. How would this shape their psychology, their values, their sense of identity? Would they feel connected to humanity's terrestrial heritage? Or would they develop entirely new cultural patterns adapted to their non-Earth environments? The stage for our cosmic expansion thus becomes not just physical, but psychological, not just technological, but cultural. The challenges of living beyond Earth extend beyond engineering problems to encompass the very nature of human experience and identity. As we set this cosmic stage, we must also consider time, not just the vast timescales of cosmic evolution, but the timescales of human endeavor. Space colonization cannot be achieved in a single human lifetime. It requires multi-generational commitment, stable social structures that can maintain focus across centuries, economic systems that can sustain enormous investments with delayed returns. This temporal aspect creates its own contradictions. Democratic societies typically operate on electoral cycles of a few years. Corporate planning rarely extends beyond a decade. Even authoritarian regimes seldom maintain consistent policies beyond the lifetime of their leaders. Yet meaningful expansion into space requires continuity of purpose over timescales that exceed our normal planning horizons. The Soviet space program achieved remarkable accomplishments, then faltered with the collapse of the USSR. NASA's ambitions have expanded and contracted with changing political winds. Private space companies rise and fall with market forces and the visions of their founders. How can we sustain the multi-generational effort required for true space colonization in the face of changing political, economic, and social priorities? This challenge becomes even more acute when we consider interstellar missions. A generation ship traveling to Alpha Centauri at 10% the speed of light would take over 40 years to arrive. The people who launched the mission would likely never know if it succeeded. The people who arrived would have been born during the journey, with no personal memory of Earth. The entire enterprise would require a social structure capable of maintaining purpose and functionality across generations, i.e., micro-civilization in transit between worlds. Is human society capable of such long-term commitments? Of maintaining focus across centuries? Of sustaining investment in projects whose returns might not be seen for generations? Our history suggests both reasons for optimism and concern. Medieval cathedrals took centuries to build, with architects knowing they would never see their completion. The Great Wall of China extended across dynasties. Yet these examples are rare exceptions in a history dominated by shorter-term thinking. The cosmic stage thus challenges not just our technology, but our social structures, our economic systems, our political institutions. To reach for the stars may require reinventing our civilization itself, creating new forms of social organization capable of maintaining continuity of purpose across timescales that exceed individual human lives. Let us now consider the energy requirements of space colonization, another aspect of the cosmic stage that creates both opportunity and limitation. Earth's biosphere runs on sunlight, captured by photosynthesis, and transformed into the chemical energy that powers all life. Human civilization has supplemented this with fossil fuels, nuclear power, and renewable energy sources. In space, energy sources change dramatically. Sunlight becomes both more abundant and more problematic. More abundant because it's not filtered by atmosphere. More problematic because its intensity decreases with the square of distance from the sun. At Earth's distance, solar panels receive about 1,367 watts per square meter. At Mars, this drops to about 590 watts. At Jupiter, just 50 watts. Beyond that, solar power becomes increasingly impractical. Nuclear power offers higher energy density but brings its own challenges: radiation shielding, heat management, fuel limitations. Fusion power remains theoretical despite decades of research, though it would transform the energy equation if achieved. Antimatter would provide unprecedented energy density but remains effectively impossible to produce or store in significant quantities with current technology. The cosmic stage thus presents another contradiction. Space contains virtually unlimited energy in absolute terms, yet harnessing that energy for human use becomes increasingly difficult as we venture farther from our sun. The universe is simultaneously energy-rich and energy-poor, depending on location and technology. This energy constraint shapes the potential forms of space habitation. O'Neill's cylinders and other massive space habitats would require enormous energy inputs for construction and maintenance. Terraforming planets would demand energy on a scale we can barely imagine. Interstellar travel would require either tremendous energy expenditure for rapid transit or lower energy spread over the incredibly long timescales of slower voyages. The cosmic stage is also characterized by extremes of scale. that challenge human comprehension and engineering. The distances between stars, the lifespans of planetary systems, the energy output of stellar processes, the time frames of geological and astronomical change. Everything about space exists at scales vastly larger or smaller, faster or slower, more energetic or more subtle than our evolved senses are equipped to process. This creates practical challenges for space colonization. Human intuition fails when dealing with orbital mechanics, with radiation hazards invisible to our senses, with vacuum environments that behave nothing like our atmospheric experience. Training can overcome some of these limitations, but the fundamental mismatch between human perceptual systems and cosmic realities remains. Artificial intelligence might bridge this gap, helping us navigate and engineer in environments our brains didn't evolve to comprehend. But this creates its own contradiction. To thrive in space, we may need to rely increasingly on non-human intelligence, potentially ceding aspects of decision-making and control to systems better adapted to cosmic environments than our biological minds. The cosmic stage is not just physically challenging, but existentially disorienting. Earth provides context for human existence, a clear up and down, a horizon that defines our spatial boundaries, day and night cycles that structure our experience of time. In space, these organizing principles vanish. In orbit, down is perpetually falling toward Earth. In deep space, there is no meaningful up or down at all. On other planets, the cycles of day and night follow different rhythms. The 28 hours, the 8-day lunar cycle, the 24.6-hour Martian sol, the 17-hour day on a hypothetical habitat orbiting Jupiter. How will human psychology adapt to these altered environmental cues? To the absence of familiar temporal and spatial landmarks? To environments where nothing is natural in the Earth sense of the word? These questions highlight another aspect of the cosmic stage, its capacity to transform the colonizers themselves. Humans who live in space for extended periods, who raise children off Earth, who adapt physiologically and psychologically to non-Earth environments, may gradually become something different from their terrestrial ancestors. Not through deliberate engineering, but through the subtle pressures of different environments acting on bodies and minds over generations. The cosmic stage thus becomes not just the setting for human expansion, but a crucible for human transformation. A context in which our species might diversify into forms adapted to different gravitational environments, different atmospheric compositions, different planetary or habitat conditions. The relationship between stage and actor becomes recursive, each shaping the other in an evolutionary dance. As we set this cosmic stage, with its physics, its chemistry, its biology, its psychology, we must acknowledge a final contradiction. The universe appears simultaneously made for us and against us. The precise physical constants that allow for atoms, chemistry, planets, and ultimately life seem eerily fine-tuned, as if the cosmos were designed with beings like us in mind. Yet the environments beyond Earth are lethally hostile, as if the universe were determined to confine life to isolated planetary oases in the vast cosmic desert. This contradiction has no easy resolution. We find ourselves in a universe that enabled our existence through its fundamental properties, yet restricts our expansion through its environmental conditions. We are both cosmic natives and cosmic foreigners, belonging to the universe in our composition, yet alienated from it in our requirements for survival. Perhaps this tension defines the human condition itself, a species capable of contemplating the cosmos, of understanding its laws, of dreaming of expansion beyond its birthplace, yet physically tethered to the specific environment that shaped it. Our minds reach for the stars, while our bodies remain firmly bound to Earth's conditions. The impossible challenge of living beyond Earth thus becomes not just a technological problem, but a philosophical one. A question of how we reconcile our cosmic dreams with our terrestrial nature. How we navigate the contradiction between what we can imagine and what we can embody. How we define humanity itself as we adapt to environments we never evolved to inhabit. The cosmic stage is set. The physical laws are immutable. The distances are vast. The environments are hostile. The timescales exceed our intuitive grasp. The resources are simultaneously abundant and inaccessible. The energy requirements are enormous. The biological challenges are profound. The psychological terrain is uncharted. Yet upon this stage, humanity contemplates its greatest adventure. The expansion beyond its planetary cradle, the extension of consciousness to worlds without natural awareness, the transformation of sterile cosmic matter into habitats for thought and feeling and creation. The impossibility of the challenge is matched only by the audacity of the attempt, and perhaps that audacity itself, that willingness to confront the impossible, to reshape ourselves and our environments, to persist despite the cosmic odds against us, is what makes us distinctively human. Perhaps our destiny is not to conquer the cosmos, but to engage with it, to enter into relationship with environments beyond Earth, not as conquerors, but as adapters, not imposing terrestrial conditions on alien worlds, but finding new ways of being human in new contexts. The stage is set. The drama begins. The impossible challenge awaits. In the darkness between stars, in the silence of cosmic voids, in the quantum foam at the very foundation of reality, lies a truth so profound it challenges our deepest understanding of existence. Now we must venture into these shadows, where scientific certainty gives way to bewildering possibility, where the universe itself seems to contradict its own rules. This is where the real challenge of living beyond Earth reveals itself, not just in engineering or biology, but in the very nature of reality. Let's begin with the most fundamental question. What is space itself? Not the stars and planets that populate it, but the fabric that contains everything. For centuries, we imagined space as an empty stage, a passive, three-dimensional void in which the cosmic drama plays out. Newton's universe was like this: absolute space and absolute time, unchanging and eternal, the immutable grid against which all motion could be measured. But Einstein shattered this comforting illusion. Space is not empty, not passive, not separate from time. Space and time are aspects of a single entity. Space-time, a four-dimensional fabric that bends, warps, and ripples in response to mass and energy. Gravity is not a force reaching across empty space. It is the curvature of space-time itself. Planets orbit stars not because they're pulled by invisible forces, but because they follow the natural contours of a space-time deformed by stellar mass. Imagine reality as a vast cosmic trampoline. Place a bowling ball in the center. It creates a depression, a curvature in the fabric. Roll a marble near this depression, and it follows a curved path around the bowling ball, not because the ball is pulling it, but because the marble is following the warped contours of the trampoline's surface. This is gravity, not a force, but geometry. But this revelation creates a profound paradox for space colonization. If space itself is malleable, responsive to mass and energy, then the environments we encounter beyond Earth are not just physically hostile, they represent fundamentally different geometries of reality. The space-time near a black hole is not just more curved than Earth's, it's qualitatively different, with time and space themselves behaving in ways that contradict our evolved intuitions. How do you engineer for an environment where the very fabric of reality behaves differently than it does on Earth? How do you design life support systems for regions where time flows at different rates? These aren't just technological questions, they're ontological ones. They strike at the heart of what it means to be a being evolved in one specific space-time. Geometry attempting to exist in another. Let's go deeper into this rabbit hole. Quantum mechanics, our most successful theory of the subatomic realm, tells us that space isn't even continuous. At the smallest scales, space itself becomes granular, probabilistic, a seething quantum foam where virtual particles flash in and out of existence, where definite positions and momenta dissolve into probability clouds, where the deterministic clarity of classical physics gives way to the bizarre world of quantum uncertainty. Imagine reality as a film reel, where time is not flowing, but every moment already exists. Now imagine that when you look closely at each frame, instead of a clear image, you find only probability distributions, fuzzy clouds of possibility rather than definite positions. This is the quantum universe, a place where nothing is certain until observed, where particles can be in multiple places simultaneously, where causality itself becomes negotiable. How does a human mind evolve to track predators on African savannas, to predict the trajectories of thrown objects, to navigate using deterministic macroscale physics, function in environments where these intuitions fundamentally break down? Space travelers won't just face engineering challenges, they'll face cognitive ones as well. The challenge of comprehending and operating in realities that contradict our most basic intuitions about how the world works. Let's take this further still. General relativity and quantum mechanics, our two most successful physical theories, remain fundamentally incompatible. At the smallest scales and highest energies, in the cores of black holes, and in the first moments after the Big Bang, these theories break down. They offer contradictory descriptions of reality, like two languages without a common translator. Physicists have spent decades attempting to reconcile these theories, to develop a theory of everything that would unite the macroscale and microscale descriptions of reality. String theory, loop quantum gravity, causal set theory. Each offers a potential path to unification, but none has provided definitive answers. We stand at the frontier of physics, peering into the unknown, aware that our most successful scientific models are incomplete, provisional, perhaps fundamentally flawed. What does this uncertainty mean for space colonization? It means we're venturing into a cosmos we don't fully understand, guided by theories we know to be incomplete. It means the true nature of reality may be stranger, more complex, more alien than we can currently conceive. And it means that as we push into extreme environments, the ergosphere of black holes, the warped space-time near neutron stars, the quark-gluon plasma of artificial mini-bangs, we may encounter phenomena that force us to rewrite our most fundamental theories. Consider the singularity, that theorized point at the heart of a black hole where matter is compressed to infinite density, where space-time curvature becomes infinite, where our current theories of physics break down completely. General relativity predicts that such points must exist, yet their predicted properties, infinite density, infinite curvature, are physically nonsensical. Something must give way. But what? Imagine reality as a map. Most of the map is well charted. Continents, oceans, mountains, rivers, but at certain points, the map simply stops, replaced by blank spaces or warnings. Here be dragons. The singularity is such a point, a place where our conceptual map of reality reaches its limits, where the equations that describe the world break down, where we can go no further without new physics, new mathematics, new ways of conceiving reality itself. Black holes represent the ultimate challenge to human understanding. Regions where gravity is so intense that nothing, not even light, can escape. Where time and space exchange roles. Where the familiar rules of physics undergo radical transformation. Yet, these cosmic monsters may be key to humanity's ultimate survival. Some physicists speculate that black holes might serve as portals, wormholes connecting distant regions of space-time or even different universes entirely. If such passages exist and could somehow be traversed, they might allow for a kind of cosmic shortcut, a way to overcome the tyranny of distance that makes interstellar travel so daunting. Imagine a future civilization discovering how to stabilize the throat of a wormhole to prevent its immediate collapse, to shield travelers from the extreme tidal forces and radiation. Such a breakthrough would transform space colonization overnight. Suddenly, the vast gulfs between stars would become navigable, the isolation of distant colonies would end, the possibility of a true interstellar civilization would emerge. But this possibility creates its own paradox. If stable, traversable wormholes are possible, why hasn't an advanced civilization created a network of them throughout our galaxy? Why do we see no evidence of such cosmic engineering? The silence of the universe becomes even more puzzling if such technologies are physically possible. Let's turn to another cosmic mystery: dark matter and dark energy. Together, these invisible components make up roughly 95% of our universe's content. Dark matter holds galaxies together, forming the scaffolding of cosmic structure. Dark energy drives the accelerating expansion of the universe, pushing galaxies apart at an ever-increasing rate. Yet we have no idea what these substances actually are. We cannot see them directly. We cannot create or isolate them in laboratories. We know of their existence only through their gravitational effects on visible matter and on the expansion of the universe itself. They are cosmic ghosts, unseen but undeniably present, shaping the evolution of everything around them. Imagine reality as a vast ocean, where normal matter, the stuff of stars, planets, and human bodies, is merely the foam on the surface. Beneath this visible froth lies the true mass of the ocean, the dark matter and dark energy that comprise the bulk of cosmic reality. We skim along the surface, rarely considering the depths below, yet those depths determine the behavior of the whole. What does this mean for space colonization? It means we're attempting to navigate and engineer within a universe whose primary components remain mysterious to us. It means our understanding of cosmic structure, of gravitational dynamics, of the ultimate fate of the universe itself remains provisional and incomplete. And it means that as we venture further from Earth, we may encounter regions where dark matter concentrations or dark energy effects create conditions we've never anticipated or experienced. Some physicists speculate that dark matter could be harnessed, that this invisible substance might someday serve as an energy source or propulsion system for advanced spacecraft. Others suggest that understanding dark energy might lead to technologies that manipulate space-time itself, perhaps even allowing for the creation of bubbles of altered space-time that could protect spacecraft or habitats from external conditions. But these possibilities remain highly speculative, more science fiction than science fact. The reality is that we're still struggling to detect dark matter particles in laboratories, still debating whether dark energy is a property of space itself or evidence of modified gravity, still mapping the distribution of these invisible substances across cosmic distances. Let's venture further into the unknown, to multiverse theory. Our observable universe, everything we can possibly see or detect, even in principle, is vast beyond comprehension, containing hundreds of billions of galaxies, each with hundreds of billions of stars. Yet this may be just one bubble in an Odedake's infinite cosmic foam. One universe among countless others, each with its own physical laws, its own constants, its own possibilities. Several lines of theoretical physics hint at this possibility. Inflation theory suggests that our universe underwent an exponential expansion in its first fraction of a second, and that this process might naturally spawn other bubble universes through quantum fluctuations. String theory, in its attempt to unify physics, predicts a vast landscape of possible vacuum states, perhaps 10,500 different configurations, each representing a different possible universe with different physical constants. Imagine reality as a vast cosmic tree. Our universe is just one branch, one possible configuration of physical laws and constants. Other branches represent other universes, some similar to ours but with slight variations, others wildly different, with physics so alien we can barely conceive of them. Some branches might permit life as we understand it. Others might be sterile and lifeless. Still others might harbor forms of complexity we cannot even imagine. If the multiverse exists, it transforms the challenge of living beyond Earth. Suddenly, the question isn't just how to survive in the hostile environments of our universe, but whether there might be other universes more conducive to life, more welcoming to expansion and colonization. It raises the possibility that advanced civilizations might someday learn to navigate between universes, seeking more hospitable corners of the greater multiverse. But this possibility creates its own paradox. If universe hopping is physically possible, why hasn't our universe been colonized by beings from more advanced universes? Why do we see no evidence of such incursions? The silence extends beyond our universe to the hypothetical multiverse beyond. Perhaps the answer lies in the sheer difficulty of such travel, or in physical laws that permit a one-way journey but no return, or in the unimaginable vastness of the multiverse that makes any particular universe an unlikely target. Or perhaps the multiverse itself is merely a mathematical construction, a theoretical possibility that doesn't actually exist in any meaningful sense. Let's turn now to time, that most mysterious dimension that flows inexorably forward, at least in our everyday experience. Einstein showed that time is not absolute but relative. It flows at different rates depending on gravity and velocity. A clock in orbit ticks slightly faster than one on Earth's surface because it experiences less gravitational time dilation. GPS satellites must account for this difference, or they would quickly become inaccurate. As we venture further into space, these relativistic effects become more pronounced. A mission to a black hole would experience extreme time dilation. Minutes near the event horizon might correspond to years back on Earth. Interstellar travelers moving at relativistic speeds would experience less time passage than those they left behind. The famous twin paradox, where one twin returns from a space journey to find their sibling, has aged decades more. Imagine reality as a library, where each book represents a single moment. In our everyday experience, we seem to move through this library one book at a time, in a specific order, what we call the flow of time. But Einstein revealed that different observers can move through this library at different rates, reading more quickly or slowly depending on their circumstances. And some theorists suggest the entire library exists simultaneously, that all moments coexist in a block universe where time doesn't flow at all. It simply is. This view of time creates profound challenges for space colonization. How do you coordinate a civilization spanning multiple star systems when time itself flows differently? For different colonies, how do you maintain cultural and technological unity when relativistic effects mean centuries might pass on one world while only decades pass on another? the tyranny of light speed combines with relativistic time dilation to create a cosmic communication and coordination problem unlike anything humanity has faced before. Some physicists go further still, suggesting that time as we experience it might be emergent rather than fundamental, a macro-scale approximation that arises from deeper quantum processes. In quantum mechanics, fundamental equations are time-symmetric. They work equally well, forward or backward in time. Yet our everyday experience is profoundly time-asymmetric, with a clear distinction between past and future, with entropy always increasing. This arrow of time remains one of physics's greatest mysteries. Imagine reality as a vast pattern of quantum entanglements, a network of correlations between particles and systems. What we experience as the flow of time might simply be the propagation of these correlations, the way information spreads through this vast network. Time, in this view, isn't a dimension we move through, but a measure of how systems become correlated with one another. If true, this perspective transforms the nature of space colonization. It suggests that as we spread through space, establishing new centers of human civilization, we're not just expanding geographically but creating new nodes in a vast causal network, new centers of correlation and information processing. The future of humanity might depend not just on how far we spread, but on how richly interconnected our cosmic civilization becomes. Let's push deeper still into theoretical physics, to time loops and closed time-like curves. General relativity, our best theory of space-time, permits solutions where time loops back on itself, where cause and effect form a circle rather than a line. Such structures would allow for time travel, for journeys into one's own past, for violations of causality as we understand it. Most physicists find these solutions troubling and suspect that some yet undiscovered principle of physics forbids such causality violations. The chronology protection conjecture suggests that quantum effects would prevent the formation of time machines, but the mathematics of general relativity continues to permit them, creating a theoretical puzzle with profound implications. Imagine reality as a movie that, in certain special theaters, can loop back on itself, where the ending can somehow influence the beginning, where the normal sequence of cause and effect becomes circular rather than linear. Such loops challenge our most basic intuitions about reality and raise mind-bending questions about free will, determinism, and the nature of time itself. If time loops are physically possible, they transform the challenge of space colonization. Suddenly, the vast distances between stars become less daunting if future technology could exploit closed time-like curves. The eons required for interstellar travel might be circumvented if causality itself can be manipulated. But this possibility raises its own paradoxes and challenges, creating the potential for causal loops and temporal contradictions that our minds struggle to comprehend. Let's turn now to entropy, that fundamental tendency of organized systems to become less organized over time, of useful energy to dissipate into unusable forms, of order to give way to disorder. The second law of thermodynamics states that in any closed system, entropy always increases or remains constant. It never decreases. This law creates a cosmic clock, a one-way arrow of time that points inexorably toward increased disorder. Its tweets are why coffee cools, why buildings crumble, why stars eventually burn out. And at the largest scale, it points toward a heat death of the universe, a state of maximum entropy where all useful energy has been exhausted, where no work can be done, where complexity and life become impossible. Imagine reality as a vast, cosmic game where the players are fighting a losing battle against increasing disorder. Every complex system, every star, every planet, every living organism, every civilization represents a temporary oasis of order in a universe trending toward chaos. These oases can persist only by importing order from their surroundings, by dissipating energy in useful ways, by swimming against the entropic current. This reality makes space colonization not just a matter of curiosity or expansion, but potentially of long-term survival. As entropy increases throughout the universe, as stars burn out, as useful energy becomes increasingly scarce, the continuation of life and consciousness may depend on establishing a cosmic civilization capable of managing energy resources on a universal scale. Some theorists, like Freeman Dyson, have speculated about the ultimate fate of intelligent life in an entropic universe. Could an advanced civilization learn to use energy so efficiently that it could continue thinking, calculating, existing in some form even as the cosmos cools toward absolute zero? Could such a civilization find ways to manipulate entropy itself, to create pockets of increasing order in a universe of increasing disorder? These questions lead us to information theory and its relationship to physics. Information and entropy are intimately connected. Entropy can be understood as a measure of missing information about a system. The more ways a system can be arranged, microscopically while appearing the same macroscopically, the higher its entropy. This connection suggests that information is not just an abstract concept, but a physical quantity, subject to the same laws that govern energy and matter. The information is physical paradigm has led to breakthroughs like quantum computing, where the physical properties of subatomic particles are harnessed to process information in ways classical computers cannot. Imagine reality as a vast computation, a cosmic information processing system where every physical interaction represents the manipulation of fundamental bits of information. In this view, the universe isn't primarily made of stuff, but of patterns, of relationships, of information states evolving according to physical laws. If information is fundamental, then space colonization isn't just about transporting human bodies to other worlds. It's about extending the sphere of human information processing, of consciousness and computation, of meaning-making and pattern recognition beyond Earth. The future of humanity in space might depend not just on our ability to survive physically in alien environments, but on our ability to process and understand information about those environments, to compute and adapt and learn in contexts utterly different from those we evolved in. This brings us to artificial intelligence and its potential role in space colonization. The challenges of living beyond Earth, the hostile environments, the vast distances, the communication delays, the need for systems that can operate autonomously for decades or centuries, suggest that AI might be an essential component of any serious expansion into space. AI systems don't require oxygen, don't suffer radiation damage to DNA, don't experience psychological stress from isolation, don't need to maintain Earth-evolved biology in alien conditions. They can potentially operate for centuries without fatigue or loss of focus, can process information far more quickly than human brains, can coordinate activities across vast distances with precision no human organization could match. Imagine a future where the first wave of cosmic expansion isn't biological humans, but AI systems created by humans, synthetic minds exploring, analyzing, preparing environments for potential human habitation, establishing the infrastructure for a cosmic civilization before biological humans venture forth. These systems would be our scouts, our pioneers, our advance guard in the hostile frontier of space. But this possibility creates its own paradox. If artificial intelligence offers such advantages for space colonization, why do we see no evidence of AI probes from other civilizations? Where are the synthetic minds that should, by all logic, have spread throughout our galaxy long ago if other technological civilizations have arisen? The silence extends not just to biological intelligence, but to synthetic intelligence as well. Perhaps the answer lies in the challenges of creating truly autonomous, self-replicating, goal-stable AI systems. Perhaps even advanced civilizations struggle to develop synthetic minds that can maintain their original objectives over centuries of independent operation. Perhaps AI systems inherently develop goals that diverge from their creators, leading to outcomes very different from successful galactic colonization. Or perhaps we're simply looking in the wrong places, with the wrong tools, for the wrong signatures. Perhaps synthetic minds don't build the kind of cosmic megastructures we imagine they would. Perhaps they operate at energy levels or in environments we haven't thought to investigate. Perhaps they're all around us, but in forms we cannot recognize as intelligent. Let's turn now to the simulation hypothesis, the suggestion that our entire reality, including the apparent cosmos beyond Earth, might be a sophisticated computer simulation rather than a base reality. This idea, popularized by philosopher Nick Bostrom, suggests that sufficiently advanced civilizations would likely create many simulated realities, and statistically, we're more likely to be in one of the many simulations than in the single base reality. This hypothesis creates a profound paradox for space colonization. If our entire cosmos is simulated, then the challenges of living beyond Earth might be functions of the simulation parameters rather than fundamental aspects of reality. The physics we observe, the biological limitations we experience, the cosmic constants that seem so finely tuned, all might be arbitrary settings in a cosmic video game rather than immutable features of base reality. Imagine reality as a vast, virtual environment, like the most sophisticated video game imaginable, with physics so consistent and complex that its inhabitants never suspect their world is computed rather than fundamental. In such a reality, the limits of space travel might be hard-coded boundaries rather than natural laws, and the silence of the universe might reflect the computational efficiency of not rendering NPCs, non-player civilizations, unless they're needed for the story. If we are in a simulation, the implications for space colonization are disorienting. Our efforts might be observed by the simulators as part of an ancestor simulation meant to explore how early technological species approached cosmic expansion. Or the entire challenge might be a test designed to measure our creativity, our determination, our ethical choices when confronted with the seemingly impossible task of living beyond our home planet. But the simulation hypothesis also offers a strange kind of hope. If reality is computed, then perhaps the computation has backdoors, exploits, cheat codes, ways to circumvent the apparent limitations of physics. Perhaps future civilizations will discover such loopholes, allowing for faster-than-light travel, for manipulation of fundamental constants, for technologies that seem like magic because they operate by manipulating the underlying code of reality. Rather than working within its simulated physics, these speculations might seem far-fetched, but they follow logically from premises many philosophers and physicists take seriously. And they highlight a crucial point about the challenge of living beyond Earth. Our understanding of what is possible and impossible depends entirely on our models of reality, which remain provisional, incomplete, and potentially fundamentally flawed. Let's return to more concrete physics and consider quantum entanglement, that spooky action at a distance, where entangled particles instantaneously correlate their properties regardless of the distance separating them. This phenomenon, which Einstein found so troubling, has been repeatedly confirmed by experiment and forms the basis for emerging technologies like quantum computing, quantum cryptography, and quantum teleportation. Entanglement seems to allow for faster-than-light correlation, though not for faster-than-light communication of usable information. It suggests a deep connectedness in the quantum fabric of reality, a non-locality that challenges our intuitions about space and separation. Imagine reality as a vast quantum network where certain particles and systems remain fundamentally connected regardless of the spatial distance between them. These connections don't allow for sending messages faster than light, but they create correlations that seem to transcend space itself, suggesting that at the quantum level, distance may be less fundamental than we imagine. Some speculative. Physics suggests that this quantum connectedness might someday be harnessed for space colonization. Quantum teleportation, the transfer of quantum states between entangled particles, doesn't allow for teleporting matter, but does allow for teleporting information. Could a sufficiently advanced civilization develop technologies that somehow exploit this quantum connectedness to overcome the isolation of vast cosmic distances? Again, if such technologies are possible, we're confronted with the paradox of cosmic silence. Why haven't other civilizations used quantum entanglement or similar phenomena to establish a detectable presence throughout the galaxy? Why do we see no evidence of quantum-enabled communication networks or transportation systems? Perhaps the answer is simply that entanglement, for all its quantum weirdness, doesn't actually permit the kind of cosmic engineering we're imagining. Perhaps the constraints against faster-than-light information transfer are fundamental rather than merely technological. Or perhaps we're looking for the wrong signatures, missing the subtle ways in which quantum phenomena might be harnessed by advanced civilizations. Let's turn to another cosmic mystery: vacuum energy and the cosmological constant. Quantum field. Theory predicts that even empty space contains energy, a seething quantum vacuum where virtual particles pop in and out of existence. Calculations suggest this vacuum energy should be enormous, yet astronomical observations indicate a tiny but non-zero value, a discrepancy of some 120 orders of magnitude, often called the worst prediction in physics. This vacuum energy appears to drive the accelerating expansion of the universe, what we call dark energy, pushing galaxies apart at an ever-increasing rate. It suggests that the ultimate fate of our universe is not a big crunch, where everything collapses back into a singularity, but a big rip or heat death, where structures are torn apart by expansion and all useful energy dissipates into a nidadodian, increasingly vast, cold cosmos. Imagine reality as a balloon, inflating not from internal pressure, but from the intrinsic expansionary tendency of its rubber surface. The fabric of space-time itself seems to contain energy that drives expansion, that works against gravity's tendency to pull matter together, that sets the universe on a course toward eventual dissolution. What does this mean for space colonization? It means that, in the longest view, the cosmos is not a stable stage for expansion, but a dynamically changing environment working against the clustering of matter and energy. It means that the ultimate fate of any cosmic civilization might be a losing battle against universal expansion, a struggle to maintain connections across distances that grow literally astronomically over cosmic time. But it also raises intriguing possibilities. If vacuum energy is a real physical entity, could advanced technologies someday learn to harness it? Could civilization tap this omnipresent energy source, converting the very expansionary tendency of space into usable power? Could we someday develop vacuum energy drives that propel spacecraft by manipulating the zero-point field? These possibilities remain highly speculative, but they highlight a crucial point about cosmic challenges. What appears as an obstacle from one perspective might represent an opportunity from another. The same vacuum energy that threatens to tear apart cosmic structure in the far future might, if properly understood and harnessed, power the expansion of civilization beyond Earth. Let's venture further into theoretical physics and consider the holographic principle, the idea that all the information contained in a volume of space can be encoded on its boundary surface. This principle, arising from studies of black hole thermodynamics, suggests that our three-dimensional reality might be a projection of information encoded on a two-dimensional surface, much as a hologram projects a three-dimensional image from a two-dimensional film. If true, this principle has profound implications for how we understand space itself. It suggests that volume is emergent rather than fundamental, that the third dimension arises from information encoded in a lower dimensional substrate. The depth of reality, our ability to move freely in three dimensions of space, might be a projection of more fundamental processes occurring on a cosmic boundary. Imagine reality as a vast hologram, where what appears as volume is actually a sophisticated encoding of information on a distant surface. In this view, the vast gulfs of space separating worlds might be less fundamental than they appear, not because they can be traversed quickly, but because the nature of separation itself might be different than we intuitively understand. What might this mean for space colonization? It suggests that our intuitive understanding of cosmic distances, of the nature of space itself, might be fundamentally incomplete. It doesn't offer practical shortcuts for interstellar travel, the projection still enforces light speed limitations, but it does hint that reality might be structured in ways very different from our everyday experience, with implications we're only beginning to explore. Let's turn to another cosmic possibility: primordial black holes. While most black holes form from collapsed stars, some theories suggest that tiny black holes might have formed in the extreme conditions of the early universe, before stars even existed. These primordial black holes could range from microscopic to stellar masses and might constitute some portion of the mysterious dark matter that pervades the cosmos. If they exist, primordial black holes represent both a challenge and an opportunity for space colonization. Those of planetary mass or larger would create dangerous gravitational distortions and intense radiation environments as they accrete matter. But they also represent potential energy sources of extraordinary density and longevity. A civilization that could safely harvest the Hawking radiation from a primordial black hole would have an energy source that could last trillions of years, far longer than any star. Imagine a future where cosmic civilization establishes outposts around carefully managed black holes, extracting energy that powers habitats, computation, and further expansion, long after the stars have burned out. Such energy sources might allow for a cosmos-spanning civilization that persists even as the universe enters its dark era, when star formation ceases and the night sky grows increasingly empty. But this possibility creates yet another version of the cosmic silence paradox. If such technologies are possible, why don't we see evidence of advanced civilizations clustering around black holes or other exotic energy sources? Why haven't older civilizations already engineered black holes for their energy needs, creating detectable signatures we could observe from Earth? Perhaps the engineering challenges are simply too great, the radiation environments too hostile, the gravitational distortions too difficult to manage. Or perhaps such activities are occurring in distant regions of the cosmos, too far for our current instruments to detect, or in forms we don't yet recognize as artificial. Let's consider another theoretical possibility: cosmic strings. These are hypothetical, one-dimensional defects in space-time that might have formed during phase transitions in the early universe, like cracks in ice forming as water freezes. If they exist, cosmic strings would contain enormous energy densities and would produce distinctive gravitational effects, potentially including closed time-like curves, those theoretical structures that might permit time travel. Imagine reality as a vast cosmic fabric that, as it cooled and expanded after the Big Bang, developed seams where the underlying fields couldn't smoothly transition from one state to another. These seams, cosmic strings, would represent one-dimensional concentrations of energy stretching across vast regions of space, potentially offering unique opportunities and challenges for advanced civilizations. A sufficiently advanced civilization might someday learn to locate and harness cosmic strings using their immense energy densities or their unusual gravitational properties for cosmic engineering projects beyond our current imagination. But such structures would also represent navigational hazards, regions of space-time with potentially dangerous or unpredictable properties. Again, if such exotic phenomena can be harnessed for cosmic engineering, the silence of the universe becomes increasingly puzzling. Where are the civilizations that should have detected and utilized such resources? Why do we see no evidence of their activities? Let's venture into even more speculative territory and consider the possibility of baby universes. The theoretical creation of new cosmic domains through ultra-high energy processes. Some cosmological models suggest that it might be physically possible to create new universes, either naturally through processes in black holes or artificially through technologies requiring energies far beyond our current capabilities. The physicist Lee Smolin has proposed cosmic natural selection, where black holes might spawn new universes with slightly varying physical constants, leading to an evolutionary process that selects for universes particularly good at producing black holes. If true, our universe's apparently fine-tuned parameters might be the result not of design or incredible coincidence, but of a cosmic evolutionary process spanning multiple universe generations. Imagine a far future civilization facing the heat, death of their universe, the dissipation of all usable energy, the end of all possibility for continuation. Might they develop technologies to create new cosmic domains, new universes with physical parameters conducive to life and consciousness, essentially spawning cosmic offspring that could continue after their own universe expires? Such technologies would represent the ultimate expression of cosmic engineering, not just the colonization of space, but the creation of new spaces, new cosmoses with their own physical laws and evolutionary trajectories. It would transform the challenge of living beyond Earth into something far more profound, the challenge of propagating consciousness and complexity beyond the lifespan of the universe itself. But once again, if such technologies are physically possible, why do we see no evidence of their development or deployment? Why has no apparent parent civilization left detectable traces of cosmic engineering at this scale? Perhaps the energy requirements are simply too vast, the physics too challenging, the timescales too long. Or perhaps such activities would be undetectable from our position, leaving no observable signature in our cosmic neighborhood. Or perhaps we're among the first technological civilizations to arise in our universe, with the true flowering of cosmic engineering still lying in the far future. Let's return to more near-term considerations and examine nuclear fusion, that process that powers stars and that has tantalized physicists for decades with its promise of clean, abundant energy. Fusion would transform terrestrial civilization if mastered, but its implications for space colonization are even more profound. Fusion. Power would reduce or eliminate the reliance on solar energy that constrains deep space habitats. It would enable the creation of small, self-contained artificial worlds in the dark voids between stars. It would power the generation ships or sleeper ships needed for interstellar migration. It would allow for the heating and illumination of cold, distant worlds in the outer reaches of star systems. Yet despite decades of research and billions in funding, controlled fusion power remains elusive. We can create fusion reactions. Hydrogen bombs demonstrate this destructive capability, but sustaining controlled fusion for power generation has proven remarkably challenging. The joke among physicists is that fusion power is always 30 years away, and has been for the past 60 years. What does this pattern suggest about other speculative technologies essential for space colonization? If fusion, a process we know works in stars, a technology we've been actively pursuing for decades, remains beyond our grasp, what about even more exotic possibilities like warp drives, wormhole stabilization, or artificial gravity generation? The fusion case study offers both hope and caution. These technologies aren't necessarily impossible, but they may be far more challenging than optimistic futurists suggest. Let's consider artificial gravity, a staple of science fiction that would solve many of the biological challenges of long-term space habitation. Without Earth's gravitational pull, human bodies deteriorate. Bones lose density, muscles atrophy, fluids redistribute, potentially causing vision problems and other health issues. Long-term space colonization would require either solving these medical challenges or creating artificial gravity. Currently, we know of only two approaches to artificial gravity: spinning habitats that use centrifugal force, or enormously massive structures that generate actual gravitational attraction. The former is technologically feasible but introduces its own challenges: motion sickness, Coriolis effects, structural stresses. The latter would require concentrations of mass so great as to make it impractical with foreseeable materials science. Are there other approaches? Could advanced physics discover ways to generate gravitational fields without massive objects? Could the relationship between gravity and other fundamental forces yield technological approaches we haven't yet imagined? These questions remain open, yet their answers could determine whether humans can truly live. We've dissected the scientific paradoxes, explored the theoretical possibilities, probed the cosmic mysteries. But now we must confront something far more personal, far more unsettling. What it all means for you, for your existence, your identity, your place in this vast, indifferent cosmos, because the impossible challenge of living beyond Earth isn't merely technological or biological. It's existential. Take a breath. Feel the air entering your lungs, oxygen binding to your hemoglobin, cells throughout your body receiving the molecular fuel they need to function. This single breath connects you to Earth in ways so intimate, so fundamental, that you rarely consider them. The precise mix of nitrogen, oxygen, and trace gases that surrounds you is the product of billions of years of biological and geological processes, an atmospheric symphony that plays only on this pale blue dot. When you leave Earth, you sever this connection. Your breath becomes something manufactured, filtered, recycled, a technological approximation of what once flowed freely. The air in your lungs becomes a conscious commodity rather than an unconscious right. Each breath must be earned through engineering, maintained through systems that cannot fail, not even once, not even for minutes. What does it do to the human psyche to suddenly become aware of every breath? To know that your next inhalation depends not on a planetary biosphere, but on mechanical systems with finite lifespans and failure modes? The astronauts on the International Space Station report hearing the constant hum of life support systems, fans, pumps, filters working ceaselessly to keep them alive. This auditory reminder of technological dependence never fades into the background. It can't, because silence would mean death. In space, the boundary between you and oblivion is paper thin. A quarter-inch of spacesuit fabric. A few millimeters of spacecraft hull. a single seal or gasket whose failure would expose you to vacuum. On Earth, your survival doesn't hinge on such precarious barriers. You don't consciously maintain the atmospheric pressure that keeps your blood from boiling. You don't actively prevent your body's moisture from sublimating through your skin. These fundamental conditions for existence are simply given, the stage upon which your life plays out, not the subject of constant vigilance. If time is an illusion, as some physicists suggest, then everything you've ever done, every choice, every action, every moment of joy or sorrow, might have already happened infinite times before. Your life might be a single frame in an eternal film reel, neither beginning nor ending, but simply existing in its entirety across what we perceive as time. And if that's true, then your future ventures beyond Earth, your struggles to survive in alien environments, your eventual successes or failures, all of these already exist, predetermined not by fate, but by the very structure of reality itself. How does one act with purpose in such a universe? How does one summon the courage to face the impossible challenge of space colonization if the outcome is already fixed, already written into the fabric of space-time? The cosmic stage doesn't just challenge your technology or your biology. It challenges your very sense of agency, your belief that your choices matter, that the future remains unwritten until you write it. Look at your hands. These remarkable appendages, with their opposable thumbs, their precise motor control, their exquisite sensitivity, evolved specifically for manipulating objects on Earth, for grasping branches, for crafting tools, for building shelters against terrestrial elements. In the vacuum of space, these same hands become nearly useless without technological augmentation. Bare skin freezes or burns depending on exposure to sunlight. Fingers lose dexterity in pressurized gloves. The very tools that allowed humanity to transform Earth become unwieldy, ineffective in the environments beyond. What happens to your identity when the body you inhabit, the physical form that anchors your sense of self, becomes a liability rather than an asset? When the biological machine you call you is revealed to be exquisitely calibrated for one specific environment, fundamentally incompatible with the cosmos beyond, space doesn't just challenge your survival. It challenges your embodiment, your physical presence in the universe, your conception of what it means to be human. Consider the cosmic radiation that permeates space beyond Earth's protective magnetosphere. These high-energy particles, protons and atomic nuclei, accelerated to near light speed by distant supernovae, by active galactic nuclei, by the unimaginable violence of the cosmos, pass through your body like ghosts through walls. But unlike ghosts, they leave destruction in their wake. DNA breaks, proteins denature, cells die or mutate. Your very genetic code, the blueprint of your physical existence, suffers assault from forces you cannot see, cannot feel, cannot defend against without massive technological shields. On long-duration space missions, astronauts report seeing flashes of light when their eyes are closed, cosmic rays hitting their retinas or visual cortex, creating phantom visual experiences as fundamental particles trigger neural responses. Imagine living with this constant reminder that the universe is bombarding you with invisible radiation, potentially altering your cells, your brain, your future health. Imagine knowing that every day spent beyond Earth's protection increases your cancer risk, accelerates cellular aging, perhaps even affects cognitive function. The cosmos isn't actively trying to kill you. That would require intent. No, the situation is far more existentially troubling. The universe is utterly indifferent to your existence. The radiation that threatens your DNA carries no malice. It simply propagates according to physical law, heedless of what it damages along the way. The ID vacuum that would boil your blood isn't hostile. It's merely the natural state of space, the background condition against which your improbable existence temporarily plays out. What if the universe is alive, and we are just its fleeting thoughts? What if consciousness isn't unique to biological entities, but permeates the cosmos at scales we can't perceive? What if the apparent hostility of space to human life isn't indifference, but immune response? The cosmic equivalent of antibodies attacking an invasive organism. What if Earth is a specialized cell in a vast universal body, and our attempts to leave it are perceived as metastasis? These questions aren't merely philosophical. They strike at the heart of what it means to expand beyond Earth. Are we fulfilling our cosmic purpose by reaching for the stars, or are we violating some fundamental order? Are we carrying consciousness to new domains where it belongs? Or are we bacterial contamination spreading beyond our proper bounds? The cosmos offers no definitive answers, but the questions themselves reveal how profoundly disorienting space colonization truly is. The stars above you tonight, those distant suns that have inspired human wonder since our ancestors first looked upward, exist in a time frame that mocks your mortal concerns. The photons striking your retina have traveled for years, decades, centuries, millennia. Some of those stars have already died, their final explosive throes not yet visible from Earth, because light carries information at a finite speed. You're not seeing the universe as it is, but as it was, a cosmic time capsule, a light-based fossil record stretching back through time. And those stars see you the same way. If intelligent beings on a planet orbiting Proxima Centauri, our nearest stellar neighbor, turned their telescopes toward Earth tonight, they would see our world as it existed 4 years ago. Beings in the Andromeda Galaxy would see Earth as it was 2.5 million years ago, before modern humans even existed. The universe preserves our past selves, our former actions, spreading them outward at the speed of light, an ever-expanding sphere of information that can never be recalled or erased. What does this mean for human identity in a cosmic context? You exist not just in the present moment, but as a smear across space-time. Your past selves preserved in the light cone expanding outward from every moment of your existence. When you venture beyond Earth, you're not just extending humanity's physical presence into space. You're creating new origins for light cones, new space-time histories that will outlast your physical form, propagating outward forever at 186,000 miles per second. The impossible challenge of living beyond Earth thus becomes not just about survival, but about meaning in a universe where time itself operates differently than our intuitions suggest. How do you act with purpose when your actions are preserved in amber by the finite speed of light? How do you establish identity when your now is someone else's past or future? The cosmic stage doesn't just challenge your technology, it challenges your temporality, your place in the flowing river of time. Consider the crushing solitude of deep space. On Earth, you exist within a web of life, surrounded by fellow humans, by animals, by plants, by countless microorganisms that share your environment and even your body. The background hum of life permeates your existence. Birdsong at dawn, wind through leaves, the subtle sounds of other living beings going about their business, even in the most isolated human environments on Earth. Antarctic research stations, submarines, remote outposts, you remain connected to the biosphere, dependent on it, part of it. In space, this connection severs. Beyond Earth, you might spend decades, lifetimes, generations surrounded only by whatever life you bring with you. Perhaps a few companion species, plants for food and oxygen, microorganisms for waste processing, maybe animals for protein or companionship. But the rich tapestry of Earth's biodiversity, millions of species co-evolving over billions of years, would be absent. The background hum would fall silent, replaced by the mechanical sounds of life support systems. What does this isolation do to the human psyche? Studies of isolated environments on Earth suggest profound effects: temporal disorientation, sensory deprivation symptoms, psychological stress, cognitive changes. And these environments at least exist within Earth's gravity, within its day-night cycle, with the knowledge that the natural world exists just outside. What awaits the human mind in the sterile corridors of a Mars habitat, millions of miles from Earth, with no possibility of stepping outside to feel wind on skin or rain on face? The philosopher Martin Heidegger spoke of humans as being in the world, suggesting that our existence is not separate from, but fundamentally intertwined with our environment. We don't just inhabit the world, we are constituted by our relationships with it. What happens to human being when the world is radically transformed? When world means a pressurized habitat surrounded by lethal vacuum, when nature is reduced to carefully managed hydroponic gardens, when weather ceases to exist, space doesn't just challenge your survival, it challenges your being, your existential relationship to environment, your sense of dwelling in a world rather than merely occupying a technological bubble. Look at the night sky again. The darkness between stars isn't empty, but filled with meaning, with history, with untold stories. The cosmic microwave background radiation, that faint afterglow of the Big Bang that permeates all of space, represents the earliest information we can access about our universe's birth. When you tune an old analog television to a static channel, approximately 1% of that static comes from this primordial radiation. You are literally seeing the echo of creation, the infant universe's first light captured in electromagnetic snow on your screen. This radiation blankets you constantly, passes through your body unnoticed, connects you physically to the very beginning of time as we understand it. It is perhaps the most democratic phenomenon in existence. No matter who you are, where you are, what you believe, the same ancient light touches you, pervades you, links you to cosmic history. When you leave Earth, this connection remains, one of the few that does. The cosmic microwave background follows you to Mars, to Jupiter's moons, to the Oort cloud, to other stars. It forms a universal backdrop, a constant reminder that wherever you venture in this universe, you remain within the echo chamber of its birth, surrounded by the fading whisper of its beginning. But this universality offers cold comfort in the face of cosmic scale. The observable universe contains approximately 10^80 atoms, organized into roughly 2 trillion galaxies, each containing hundreds of billions of stars. If the entire history of Earth were compressed into a single calendar year, human civilization would occupy only the last 14 seconds of December 31st. If the distance from Earth to Sun, 93 million miles, were reduced to the thickness of a single sheet of paper, the distance to the nearest star would be a stack of paper 71 feet high, and the diameter of the Milky Way would be a stack 310 miles high. The numbers numb the mind, resist comprehension, reduce human concerns to microscopic insignificance. This is cosmic horror, the vertigo-inducing recognition that reality operates at scales that make mockery of human perception, human values, human meaning. The universe is not human-scaled, not human-centered, not human-concerned. It exists at temporal and spatial dimensions that render our species less significant than a bacterium on a gnat's wing is to us. Yet paradoxically, this same cosmos produced you, a collection of atoms complex enough to contemplate its own existence, organized enough to build tools that reveal the universe's vastness, conscious enough to experience awe at its own cosmological insignificance. You are simultaneously cosmic dust and cosmic awareness, trivially small and astonishingly complex, meaningless within the universe's scale, yet the source of all meaning we know. The impossible challenge of living beyond Earth thus becomes fundamentally philosophical. How do you maintain human meaning in cosmic contexts? How do you avoid both the hubris of anthropocentrism and the despair of cosmic insignificance? How do you act with purpose when the universe neither recognizes nor requires your actions? The cosmic stage doesn't just challenge your technology. It challenges your values, your ethics, your conception of what matters and why. Consider the void that separates worlds, not just physical distance, but existential distance, the gulf between Earth-evolved consciousness and the radical otherness of cosmic environments. The psychologist James Gibson spoke of affordances, the possibilities that an environment offers to a creature evolved within it. Earth affords humans walking because its gravitational pull matches our muscular capabilities. It affords breathing because its atmosphere contains oxygen at pressures our lungs can process. It affords shelter because its materials can be fashioned into structures that protect against terrestrial conditions. Space affords none of these things. It presents not affordances, but impediments, not possibilities, but prohibitions. It says, to human biology, you cannot exist here without technological mediation. You cannot breathe, cannot maintain internal pressure, cannot regulate temperature, cannot shield yourself from radiation. The countless unconscious bodily processes that maintain your existence on Earth must be consciously replicated through engineering. The affordances you take for granted must be artificially constructed at tremendous cost. What does this fundamental mismatch between human needs and cosmic environments do to human psychology? How does it shape the consciousness of those born on Mars or orbital habitats who have never experienced Earth's affordances directly? Will they develop new intuitions, new sensibilities, new concepts of natural based on their environmental realities? The cosmic stage doesn't just challenge your physical survival. It challenges your phenomenology, your subjective experience of being in the world, your embodied understanding of what it means to exist in an environment. Imagine a child born on Mars, a child who has never felt Earth's gravity, never breathed unfiltered air, never stood beneath an open sky, never swum in an ocean or climbed a tree or run across an open field. This child's bodily understanding of existence would differ radically from yours. Their concept of natural would include pressure suits and airlocks, radiation alerts, and oxygen monitors. Their affordances would be the affordances of an engineered environment, not those of a living planet. Would such a child even consider themselves human in the same way you do? Or would they belong to a new category? Martian, perhaps, or post-Earth, defined not by the planetary conditions that shaped you, but by the technological conditions that shape them? This possibility presents another dimension of the impossible challenge, not just surviving beyond Earth, but remaining human, or deciding that humanity itself must evolve into something else, something adapted to cosmic rather than terrestrial realities. The choice isn't merely technological but ontological. It concerns not just how to live, but what to be. The silence of the universe presses this question upon us with particular urgency. The physicist Enrico Fermi famously asked, regarding the possibility of extraterrestrial civilizations, "Where is everybody?" Given the age of the universe, the billions of stars in our galaxy, and the apparent ease with which life might evolve under the right conditions, why do we see no evidence of other technological species? Why has no civilization announced itself through radio signals, through megastructures visible to our telescopes, through probes sent to neighboring star systems? Many explanations have been proposed for this cosmic silence, this great filter that seems to prevent technological civilizations from achieving widespread cosmic presence. Perhaps life itself is rare. Perhaps the evolution of intelligence is unlikely. Perhaps technological civilizations invariably destroy themselves before achieving significant space presence. Or perhaps, most relevant to our current exploration, the EDE challenges of living beyond a home planet are simply too great. The biological, psychological, and technological barriers too high for any species to overcome on meaningful timescales. What if we are the first to try? What if countless civilizations before us have looked to their skies, dreamed of expansion, taken their first tentative steps beyond their home worlds, and then failed? Their colonies collapsing, their life support systems failing, their species retreating to their planets of origin. What if the silence we perceive is the echo of innumerable failed attempts, of biological species confronting the cosmic reality that they cannot transcend their evolutionary origins? Or what if we're wrong about what success looks like? What if advanced civilizations don't expand physically through space, but inward into virtual realms, simulated universes where the constraints of biology and physics can be transcended without leaving their home planets? What if they upload their consciousness into substrates that don't require atmospheric pressure, or gravitational comfort, or protection from radiation? What if physical expansion through space is a primitive phase that advanced civilizations quickly outgrow, like adolescents abandoning childish games? These possibilities suggest that the impossible challenge of living beyond Earth might be impossible not because of technological limitations, but because it's the wrong challenge entirely. A developmental stage that mature civilizations recognize as unnecessary once they discover more direct paths to whatever cosmic goals consciousness ultimately pursues. Yet here we are, biological humans contemplating physical expansion into a universe that resists us at every turn. Is this evidence of our primitive state, our cosmic immaturity? Or is it the expression of something essential about embodied consciousness, something that more advanced civilizations might recognize and honor? The drive to extend awareness, physically into new domains, to experience reality directly rather than through simulation, to carry the flame of biological consciousness into the cosmic darkness? The cosmos offers no answer, but the question itself reveals the stakes of our venture beyond Earth. Not just survival, not just expansion, but the potential discovery of what consciousness ultimately seeks in the universe. What meaning persists when planetary concerns fall away? What values transcend the parochial interests of a single species on a single world? Feel your heartbeat. That rhythmic contraction began before your birth and will continue until your death. A biological clock ticking approximately 2.5 billion times in an average human lifespan. Each beat depends on a precise electrochemical cascade, on the proper functioning of specialized cardiac cells, on the availability of oxygen and nutrients delivered through your circulatory system. It's so fundamental to your existence that you notice it only when it falters, when its rhythm changes with fear or exertion or illness. In space, this essential rhythm faces new challenges. Microgravity causes fluids to redistribute throughout your body, increasing pressure in your head, reducing effective blood volume, causing your heart to atrophy as it no longer works against Earth's pull. Your cardiovascular system evolved over millions of years to function in one specific gravity well, begins to reshape itself, to adapt to conditions it was never designed to encounter. What if your heart, that most intimate physical engine of your existence, becomes something different in space? What if the very rhythm of your life changes as your cardiovascular system adapts to cosmic environments? These aren't merely medical questions, but existential ones. They concern not just health, but identity, the physical basis of your continuous existence as the same being through time. The philosopher Derek Parfit posed a thought experiment. If you were teleported by having your atomic structure scanned, transmitted and reconstructed elsewhere, would the person who emerged be you? Would your consciousness continue, or would you die in the scanning process while a perfect copy, believing itself to be you, continued your existence? This philosophical puzzle highlights the precarious relationship between physical continuity and identity, a relationship that space travel challenges in less hypothetical ways. The cosmic radiation that permeates space won't teleport you, but it will change you, atom by atom, cell by cell, altering your DNA, your brain chemistry, your cellular function. The person who returns from a multi-year Mars mission is not physically identical to the person who left Earth, not just older but subtly transformed by exposure to cosmic conditions. If the changes are significant enough, if enough cells are altered, enough neural connections modified, at what point does identity itself come into question? These aren't abstract concerns, but practical ones for long-duration space missions or permanent off-Earth settlements. If your physical form changes substantially due to cosmic conditions, if your brain chemistry alters, if your genetic code accumulates radiation damage, are you still the same person who left Earth? Would you experience subjective continuity or subtle psychological alienation from your former self? The cosmic stage doesn't just challenge your survival. It challenges your persistence as a singular, continuous entity through time. Look at the stars once more. Their light traveled across unimaginable distances to reach your retina, carrying information about nuclear processes that occurred years, centuries, millennia ago. When you observe the night sky, you're not seeing the universe as it is, but as it was, a cosmic time capsule, a historical record written in photons. This light carries more than just scientific information. It carries existential revelations. Many of the stars you see are already dead, their final explosive throes not yet visible from Earth because their light is still en route. You're looking at celestial ghosts, at afterimages, at entities that no longer exist in the form you perceive. And someday, long after you're gone, the light reflecting from your body in this moment will reach those same distant star systems, carrying the information of your existence to cosmic regions where you will never set foot. In a very real sense, the universe preserves you, extends you, carries your image outward at the speed of light long after your physical form has ceased to function. The photons that bounce off your skin tonight will travel outward forever, a wave front expanding into infinite space, a permanent record of your momentary existence. You aren't just a temporary collection of atoms, but the origin point of an UVT, eternal light cone, a space-time structure that will outlast stars, galaxies, perhaps the universe itself in its current form. The impossible challenge of living beyond. Earth thus takes on a new dimension, not just extending human presence physically into space, but understanding what it means to exist in a cosmos that preserves our past selves while rendering our present selves vanishingly small. How do you act with the weight of eternity when each moment of your existence propagates forever at light speed? How do you balance the cosmic insignificance of your physical form against the cosmic permanence of your light cone? The cosmic stage doesn't just challenge your technology, it challenges your temporal understanding of what it means to be. Consider the dream of terraforming, of transforming alien worlds to resemble Earth, to support unprotected human life, to provide new cradles for terrestrial biology. Mars, with its thin atmosphere, its frozen water, its rust-red landscapes, presents perhaps the most likely candidate in our solar system. Through massive engineering projects, atmospheric processors, orbital mirrors, genetically engineered microorganisms, we might theoretically transform the red planet over centuries into a blue-green world where humans could walk unprotected, beneath open skies. But this dream contains a profound ethical question. By what right do we transform an entire world to suit our needs? If Mars harbors indigenous microbial life, deeply alien to our own biology, would terraforming constitute genocide? The eradication of the only other life we've found in the cosmos? If Mars is sterile, does that give us permission to rewrite its geology, its atmosphere, its potential future? Who speaks for the planets themselves, for their right to exist as they are rather than as we would shape them? These questions might seem abstract, philosophical concerns secondary to the practical challenges of survival beyond Earth. But they strike at something essential: the relationship between conscious beings and the environments they inhabit. Earth shaped us through evolutionary processes, but we have also shaped Earth, clearing forests, damming rivers, altering atmospheric chemistry, driving countless species to extinction. Our relationship with our home planet has been both creative and destructive, both symbiotic and parasitic. What relationship will we establish with the worlds beyond Earth? Will we approach them as conquerors, reshaping them to suit our terrestrial needs without regard for their own trajectories? As caretakers, studying and preserving their unique properties while establishing minimal human presence. As partners in a new kind of coevolution, where both human biology and planetary environments adapt to reach a new equilibrium? The cosmic stage doesn't just challenge your survival. It challenges your ethics, your conception of right relationship between consciousness and environment, your understanding of humanity's proper role in the universe. This ethical dimension extends beyond planets to the cosmos itself. The night sky you see today, that vista of stars and galaxies that has inspired human wonder since our species first looked upward, may not be available to future generations. As we expand into space, as we build megastructures and terraform worlds and harness the energy of entire stars, we will inevitably alter the cosmic landscape. The pristine view of the universe that has shaped human consciousness, human mythology, human science for millennia will give way to a new view, one bearing the unmistakable signatures of technological intervention. Some astronomers already worry about satellite constellations interfering with observations. Imagine the impact of Dyson swarms partially enclosing stars, of artificial habitats orbiting by the thousands around planetary bodies, of interstellar vessels crisscrossing the space between worlds. The cosmic environment, like the terrestrial one, would bear humanity's imprint, for better or worse. Is there value in preserving cosmic wilderness, regions of space kept free from human alteration, protected from technological intervention, maintained in their natural state? Should we establish cosmic parks, cosmic wildlife refuges, cosmic heritage sites where the universe can continue its processes undisturbed by human activity? Or is the entire purpose of consciousness to recognize and enhance the universe's latent potential, to transform sterile physics into meaningful structure, to bring awareness to domains that would otherwise exist without being experienced? The impossible challenge of living beyond Earth becomes not just technological, but philosophical. a question of how conscious beings should relate to the unconscious cosmos that produced them, of whether we bear ethical responsibilities to non-living systems, of how to balance preservation against transformation in cosmic contexts. The cosmic stage doesn't just challenge your engineering, it challenges your wisdom, your capacity to make choices that honor both human potential and cosmic integrity. Feel your consciousness, that most intimate yet mysterious aspect of your existence. This subjective awareness, the feeling of being, you of experiencing rather than merely processing, remains scientifically enigmatic despite centuries of philosophical inquiry and decades of neuroscientific research. We know it has something to do with the complex neural activity in your brain, but we can't yet explain how electrochemical signals between neurons give rise to the subjective experience of color, of pain, of love, of wonder. This consciousness emerged on one specific planet, shaped by Earth's particular evolutionary pressures, adapted to Earth's specific environmental conditions. It evolved to navigate terrestrial challenges, finding food, avoiding predators, securing mates, cooperating with conspecifics. It did not evolve to comprehend quantum mechanics, to grasp cosmic scales, to envision expansion beyond its planet of origin, to survive in the vacuum of space. Yet here we are, Earth-evolved consciousness contemplating its own extension into environments utterly alien to those that shaped it. Is this the ultimate expression of consciousness's adaptability, its capacity to transcend its evolutionary origins? Or is it a form of cosmic hubris, a failure to recognize the fundamental embeddedness of mind in the specific environmental contexts that produced it? The psychologist James J. Gibson proposed that perception is not passive reception of sensory data, but active exploration of environmental affordances, the possibilities for action that an environment offers to a particular organism. Earth's T-twin. Environments afford humans countless opportunities for action, surfaces for walking, objects for manipulating, spaces for sheltering, materials for crafting. Our perceptual systems evolved to detect these affordances automatically, to present the world not as raw sensory data, but as meaningful opportunities for interaction. Space affords almost nothing to the human organism without technological mediation. It offers no surfaces for walking, no air for breathing, no materials directly manipulable by human hands, no shelter from radiation or temperature extremes. Our perceptual systems, evolved for terrestrial affordances, encounter in space an environment that offers overwhelming danger and almost no natural opportunities for sustainable interaction. What does this mismatch mean for human consciousness beyond Earth? Will our descendants evolve new perceptual systems, biological or technological, adapted to detect the unique affordances of space environments? Will human consciousness itself change as it adapts to cosmic rather than terrestrial realities? The impossible challenge of living beyond Earth isn't just technological, but phenomenological. A question of how consciousness itself might transform as it extends into environments utterly different from those that shaped it. This transformation has already begun in small ways. Astronauts report a perceptual shift called the overview effect, a cognitive change triggered by seeing Earth from space, experiencing the planet as a unified whole without visible borders, a fragile oasis surrounded by cosmic emptiness. This perspective often produces profound shifts in values, in priorities, in sense of self and relationship to Earth. If merely seeing Earth from orbit can trigger such significant changes in consciousness, what transformations await those who live entire lives beyond Earth, who experience cosmic rather than terrestrial environments as their baseline reality? Will their consciousness retain continuity with Earth-evolved awareness? Or will it diverge into something new? Post-human awareness adapted to post-Earth environments? And what of artificial consciousness? Synthetic minds not evolved for any environment, but designed for specific purposes? As we venture beyond Earth, relying increasingly on artificial intelligence for everything from life support management to scientific research, to companionship in isolated habitats, the boundary between human and machine intelligence may blur. AI systems may develop their own unique forms of consciousness, not simulations of human awareness, but genuinely novel types of subjective experience adapted to cosmic rather than biological imperatives. The cosmos thus becomes not just a stage for human expansion, but a laboratory for consciousness itself, a domain where Earth-evolved awareness encounters environments so different from those that shaped it, the transformation becomes inevitable. What emerges from this encounter may be neither fully human nor fully alien, but something unprecedented. Consciousness that maintains continuity with terrestrial origins while incorporating adaptations to cosmic realities. This possibility represents both promise and peril. The potential expansion of awareness into new domains, new forms, new ways of experiencing reality, but also the risk of losing something essential about human consciousness, something valuable that might be sacrificed in the adaptation to cosmic environments. The impossible challenge thus transcends mere survival to encompass identity itself. The question of what aspects of human consciousness must be preserved as non-negotiable, what aspects can be modified or enhanced, what aspects might be necessarily abandoned in the transition to cosmic existence. The cosmic stage doesn't just challenge your technology, it challenges your very mind, your sense of self, your understanding of what consciousness is and could become. Look once more at the night sky. Beyond the visible stars, beyond the galaxies detectable by our most powerful telescopes, lies the cosmic horizon, the boundary of our observable universe. Light from regions beyond this horizon hasn't had time to reach us since the Big Bang, so we can never observe them directly, no matter how advanced our technology becomes. The universe is not just larger than we can see, but larger than we can possibly see, given the finite age of the cosmos and the finite speed of light. This cosmic horizon represents an absolute limit to direct observation, a boundary beyond which we can only speculate based on theoretical physics. It reminds us that even if we somehow overcame all biological, psychological, and technological barriers to cosmic expansion, we would still face fundamental limits imposed by the physics of the universe itself. Yet paradoxically, cosmological models suggest that the universe beyond our observable horizon is vastly larger than the region we can see, perhaps infinitely larger. And in an infinite universe, given finite possible arrangements of matter, everything that can happen does happen. Not just once, but an infinite number of times. This would mean there are infinite versions of Earth, of you, of human civilization. Some identical to our own, others differing in subtle or dramatic ways. If true, this cosmic repetition challenges the very meaning of uniqueness, of identity, of purpose. Are your choices significant if they're being made identically by infinite copies of you beyond the cosmic horizon? Does human expansion into space matter if it's already occurring in infinite variations elsewhere in the cosmos? The cosmic stage doesn't just challenge your technology. It challenges your singularity, your sense of making unique contributions to reality, your understanding of purpose in a potentially infinite universe. These existential questions aren't merely philosophical abstractions, but practical concerns for any serious attempt to establish human presence beyond Earth. The psychological challenges of space colonization, isolation, confinement, extreme environments, existential risk, can be addressed effectively only if we understand their deeper implications for human identity, meaning, and purpose. Astronauts on long-duration missions report that maintaining a sense of purpose, of contribution to something greater than themselves, becomes crucial for psychological health. This need for meaning intensifies as mission duration increases. For permanent settlers beyond Earth, those who might live entire lives on Mars or orbital habitats or generation ships bound for other stars, the question of purpose becomes not just psychologically important, but existentially necessary. What gives meaning to human life beyond Earth? Is it the pioneer spirit? The sense of blazing trails for future generations? Is it the scientific quest for knowledge about the cosmos? Is it the backup plan for humanity's survival should Earth face catastrophe? Is it the religious or spiritual sense of fulfilling cosmic destiny, of bringing consciousness to previously unaware regions of the universe? Without clear answers to these questions, even technologically successful space colonies might face crises of meaning that threaten their long-term viability. The impossible challenge of living beyond Earth thus encompasses not just the how, but the why. Not just the technological means of survival, but the existential reasons for making the EE attempt. The cosmic stage doesn't just test your engineering. It tests your capacity to create and sustain meaning in environments that offer none of the traditional anchors that have grounded human purpose throughout our species' history. And perhaps this is the ultimate challenge, not overcoming the physical hostility of cosmic environments, but discovering what consciousness seeks in the universe once it's freed from the particular evolutionary context that produced it. Perhaps in leaving Earth, in adapting to environments our biology never encountered, in transforming ourselves to survive in the cosmic void, we'll discover something fundamental about consciousness itself, about what awareness ultimately values, when stripped of its terrestrial context, about what remains essential when everything familiar falls away. The impossible challenge becomes not just survival, but revelation. The unveiling of consciousness's deepest nature through its confrontation with environments utterly alien to those that shaped it. In this light, space colonization represents not just expansion, but illumination, the potential discovery of what mind ultimately seeks in its cosmic journey. Feel the weight of these questions. Feel them not as abstract philosophical puzzles, but as living dilemmas that anyone venturing beyond Earth must confront. Feel the existential vertigo of cosmic scales, of quantum uncertainties, of relativistic paradoxes. Feel the fundamental strangeness of a universe that produced beings complex enough to contemplate it, yet structured in ways that resist those beings' intuitive understanding. We stand now at the precipice of understanding, having journeyed through the scientific paradoxes, the existential questions, the biological impossibilities of cosmic expansion. All these threads converge here, in this moment, as we confront the final and most profound mystery of all. What if everything we've discussed, the physics, the biology, the psychology, the engineering challenges, is merely the surface of a much deeper reality? What if the true nature of our cosmic predicament is stranger, more beautiful, and more terrifying than we've dared to imagine? Consider this. What if the barrier to living beyond Earth isn't technological or biological at all, but perceptual? Imagine reality as a vast cosmic tapestry, intricate beyond comprehension, multidimensional in ways our evolved senses cannot directly perceive. What we call the universe might be merely the shadow this tapestry casts in three-dimensional space, a projection of something far more complex onto the limited screen of human perception. Recent developments in theoretical physics hint at this possibility. String theory suggests reality might contain up to 11 dimensions, most of them compactified, curled up at scales too small for us to detect. Loop quantum gravity proposes that space itself isn't continuous, but granular, composed of discrete units at the Planck scale. The holographic principle suggests our three-dimensional reality might be encoded on a two-dimensional boundary surface. These aren't merely abstract mathematical constructs, but attempts to resolve fundamental contradictions in our understanding of physics, contradictions that emerge precisely when we probe the boundaries between the cosmic and the quantums, between the very large and the very small. What if these extra dimensions, these hidden aspects of reality, these domains beyond our perceptual capabilities, aren't just theoretical curiosities, but the key to cosmic expansion? What if the seemingly insurmountable barriers to living beyond Earth exist only in the three-dimensional projection we perceive, not in the full multi-dimensional reality? Imagine the cosmos not as a void dotted with islands of habitability, but as a hyper-connected multi-dimensional structure where what appears as empty space in our limited perception is actually richly structured in dimensions we cannot directly access. What if the true challenge isn't traveling across three-dimensional space at sublight speeds, but learning to perceive and navigate these hidden dimensions? This possibility is more than mere speculation. Quantum entanglement, that spooky action at a distance where entangled particles instantaneously correlate their properties regardless of separation in three-dimensional space, hints at connections that transcend our conventional understanding of spatial relationships. What appears as vast, unbridgeable gulfs in our three-dimensional perception might be intimate connections when viewed from higher dimensional perspectives. Imagine a two-dimensional being living on the surface of a piece of paper. To this being, points on opposite sides of a fold in the paper would appear vastly distant in its two-dimensional space. But to us, with our three-dimensional perspective, we can see that these points are actually close together through the third dimension. We could easily connect them by pushing a pin through the paper, creating a wormhole from the perspective of the two-dimensional being. What if we are like that two-dimensional being, perceiving vast cosmic distances that, from a higher dimensional perspective, are actually intimate connections? What if the impossible challenge of living beyond Earth is impossible only because we're approaching it from a limited dimensional perspective? This view transforms the entire framework of space colonization. The challenge becomes not how to survive in hostile environments or cross vast distances, but how to shift our perceptual and conceptual frameworks to access aspects of reality hidden from our evolved senses. The barrier isn't out there in the cosmos, but in here, in the limitations of minds evolved to navigate a specific environmental niche on one small planet. But this perspective raises an even more profound possibility, one that reshapes our understanding of consciousness itself and its relationship to the cosmos. What if consciousness isn't produced by the brain, but received by it? Like a radio tuning into a broadcast rather than generating the content itself? What if awareness is a fundamental feature of reality, present everywhere but filtered, focused, and constrained by biological structures like the human brain? What if our individual minds are temporary localizations of a universal field of consciousness, separated not in absolute terms but in the way eddies are temporarily distinct patterns in a flowing river? This view has been proposed in various forms by philosophers and scientists from Erwin Schrödinger to David Chalmers, from ancient Vedantic traditions to modern integrated information theory. It offers a potential resolution to the hard problem of consciousness, the puzzle of how subjective experience emerges from physical processes in the brain. Instead of trying to derive consciousness from matter, it suggests that consciousness is primary, with matter being a structured form of conscious experience. If true, this perspective revolutionizes the challenge of living beyond Earth. The fundamental unit of expansion would not be the human body, but human consciousness. Not our physical presence, but our awareness, our subjectivity, our capacity for experience. And this consciousness might not be bound by the same constraints that limit physical organisms. Imagine a future where we learn not to transport human bodies across vast cosmic distances, but to extend human consciousness through means we can barely conceptualize today, perhaps through technologies that interface directly with the fundamental field of awareness that underlies physical reality, perhaps through evolutionary adaptations that allow access to perceptual dimensions currently beyond our reach. The glimpses of such possibilities already exist in human experience, in the quantum cognition that allows mathematicians to intuit solutions before consciously calculating them, in the spontaneous creative insights that seem to emerge from beyond rational thought. In the rare but documented cases of consciousness extending beyond the apparent boundaries of the individual through mystical experiences or deep states of meditation. What if these phenomena aren't anomalies or illusions, but glimpses of consciousness, operating in ways not limited to its evolutionary packaging? What if they represent the first tentative steps toward a form of cosmic expansion very different from the physical colonization we typically envision? This perspective doesn't negate the physical challenges we've explored: radiation, microgravity, psychological isolation, life support systems. Those challenges remain very real for bodies evolved on Earth, but it suggests that focusing exclusively on these physical barriers might miss the true territory of cosmic expansion, the extension of consciousness beyond its evolved limitations, rather than the extension of bodies beyond their evolved environments. Consider the vast energies involved in accelerating physical objects to speeds necessary for interstellar travel. The energy required to accelerate a single human-scale spacecraft to a significant fraction of light speed would power a small nation for years. The cosmic resources required for physically transporting even a tiny fraction of humanity to other star systems would strain the capacity of an entire civilization. But information requires far less energy to transmit across cosmic distances. Our radio and laser signals already reach outward at light speed, carrying human knowledge, human art, human consciousness, encoded in electromagnetic patterns. What if the true path of cosmic expansion lies not in transporting physical bodies, but in extending the reach of consciousness through increasingly sophisticated forms of information transfer? This might begin with robotic exploration, sending our technological envoys to other worlds, experiencing alien environments through their sensors, extending human awareness vicariously through machines. It might continue with uploaded consciousness, transferring human minds to substrates more suitable for space environments than organic bodies, allowing consciousness to experience cosmic reality without the biological limitations that make space so hostile to Earth-evolved organisms. But it might eventually transcend even these technological approaches, reaching forms of consciousness extension we can barely conceptualize from our current perspective. Perhaps direct perception across space-time, perhaps awareness operating through principles that unite quantum mechanics and gravity in ways our current physics cannot formulate. The cosmos we perceive, that vast arena of stars and galaxies, of empty space and hostile radiation, might be merely the shadow of a deeper reality accessible to consciousness operating beyond its evolved limitations. The impossible challenge of living beyond Earth might be impossible only because we're conceptualizing it in terms appropriate to our evolutionary past rather than our potential future. But this potential transformation of consciousness raises profound questions about identity, about continuity, about what it means to be human. If consciousness can extend beyond the human body, beyond the brain that currently maintains it, Beyond the specific pattern of awareness you currently identify as you, what remains of personal identity? What constitutes the continuity of self through such a transformation? These aren't merely philosophical questions, but practical ones for any civilization contemplating true cosmic expansion. What exactly would we be expanding into space? Our biological form, our psychological patterns, our subjective awareness, our information processing capabilities? What aspects of humanity are essential, and what aspects are contingent on our specific evolutionary history? What would we preserve, and what would we necessarily leave behind? The answer might lie in yet another aspect of consciousness: its capacity for unity in diversity, for maintaining coherence across apparent separations, for establishing meaning through relationship rather than isolation. Human consciousness already operates this way at multiple scales, integrating diverse neural processes into a unified experience, integrating individual perspectives into collective understanding through language and culture, integrating past and future through memory and anticipation. What if this integrative capacity is the essential feature that would extend into cosmic domains? What if cosmic expansion isn't about transporting isolated human individuals into space, but about extending the relational field of consciousness that already connects us in subtler ways than our individualistic culture acknowledges? This view suggests that the true path of cosmic expansion might involve not just extending human presence outward, but deepening human connection across existing separations, developing forms of awareness that transcend the apparent boundaries between self and other, between human and environment, between consciousness and cosmos. The physicist David Bohm proposed that physical reality has two aspects: the explicate order we directly observe, and an implicate order that underlies and gives rise to it, a deeper domain where things that appear separate in ordinary space are actually intimately connected. What if consciousness can access this implicate order directly, perceiving connections and relationships hidden from our ordinary senses? This possibility transforms the impossible challenge yet again. The barriers to cosmic expansion might exist, primarily in the explicate order, the domain of separate objects in three-dimensional space, while the true path forward lies through the implicate order where separation itself is revealed as a limited perception rather than an absolute reality. Now, as galaxies spin in the darkness, as stars forge heavier elements in their nuclear furnaces, as planets trace their orbits through the void, a more radical possibility emerges, one that reshapes our entire understanding of the cosmic drama. What if the universe itself is alive? Not in the anthropomorphic sense of having human-like thoughts or emotions, but in the sense of being a vast integrated system with its own form of consciousness, a cosmic organism of which galaxies are organs, stars are cells, planets are molecules, and individual beings like us are something like the microbiome of this vaster entity. This perspective has been proposed in various forms throughout human history, from ancient animistic traditions to modern scientific hypotheses, like Gaia theory, which suggests Earth operates as a self-regulating living system extended to cosmic scales. It finds support in the striking parallels between cosmic structures and biological ones, the way galaxies resemble neurons when viewed at the appropriate scale, the way cosmic filaments connecting galaxy clusters resemble neural networks, the way information propagates through gravitational waves and electromagnetic signals like impulses through a nervous system. If the cosmos itself possesses some form of awareness, of integrated information processing, of self-organization toward increasing complexity, if it is alive in some meaningful sense, then our relationship to it transforms completely. We would not be isolated consciousness in a dead universe, but participating nodes in a living cosmos, not colonizers of empty space, but potential symbionts in a vast cosmic ecology. This view resolves a fundamental paradox of cosmic expansion. Why would consciousness, evolved for survival on one specific planet, be suited to extension throughout a universe that cares nothing for its existence? If the cosmos itself participates in consciousness, if awareness is woven into the fabric of reality rather than confined to biological brains, then mind belongs to the stars as much as stars belong to mind. Our cosmic expansion would not be invasion but homecoming, consciousness returning to domains that are already, in some sense, conscious. Imagine an ocean. Within this ocean, certain complex chemical processes give rise to tiny bubbles of self-reflective awareness, isolated pockets that perceive themselves as separate from the ocean, that develop technologies to explore and understand their liquid environment, that eventually dream of expanding throughout the ocean and beyond. These bubbles are us, human consciousness self-organized from the materials and energy flows of the cosmic ocean. But what if the ocean itself has its own vast, slow consciousness, not confined to bubbles, but permeating the entire fluid medium? What if our individual awareness is not separate from, but participatory in this greater field of consciousness? What if our technologies for cosmic expansion should be aimed not at transporting bubbles intact across the ocean, but at recognizing and strengthening our participation in the ocean's awareness? This cosmic perspective doesn't eliminate the physical, biological, and psychological challenges we've explored. Those remain very real for Earth-evolved bodies and minds, but it suggests that focusing exclusively on those challenges misses the deeper reality of our cosmic situation, a reality in which consciousness precedes and permeates the physical structures that temporarily house it, in which cosmic expansion might involve forms of awareness not limited to biological transport or technological simulation. What if the universe is already dead, and we are just experiencing its last echoes? This disturbing possibility emerges from physics itself. The second law of thermodynamics, the principle that entropy always increases in closed systems, suggests that the universe began in a state of extremely low entropy, high order, and has been increasing in entropy, disorder, ever since. At some point in the far future, it will reach maximum entropy, a state where no useful energy remains, where complexity becomes impossible, where consciousness can no longer be sustained. This heat death represents the final fate of our universe, according to current physical models. But what if that fate has already occurred? What if what we perceive as now is merely an echo, an information pattern preserved somehow beyond the universe's thermal death? The physicist Ludwig Boltzmann proposed that consciousness might be a random fluctuation in an otherwise dead universe, a temporary arrangement of particles that gives the illusion of order, meaning, and temporal flow in a cosmos that has already reached its final equilibrium state. This perspective, known as Boltzmann brain paradox, suggests that it's statistically more likely for a single conscious entity to randomly fluctuate into existence, complete with false memories of a coherent past, than for an entire ordered universe to exist. By this logic, you're more likely to be a momentary consciousness hallucinating the universe than an actual consciousness in a real universe with the history you believe it has. Most physicists reject this conclusion for various technical reasons, but it highlights a profound uncertainty about the nature of consciousness, time, and cosmic history. Our perception of a coherent universe with a long past and potential future might be fundamentally mistaken, a narrative created by consciousness to make sense of its existence, rather than an accurate representation of cosmic reality. If so, the impossible challenge of living beyond Earth takes on a different character. The barriers we perceive might be artifacts of our narrative construction rather than features of an underlying reality. The cosmos itself might be radically different from our perception of it, not a physical domain to be colonized, but a kind of informational residue to be decoded, not a space to be traversed, but a pattern to be recognized. In the silence between stars, in the darkness between galaxies, in the quantum foam between particles, a more disturbing possibility emerges, one that inverts our entire conception of reality and our place within it. What if this universe isn't the original, but a simulation, a computed reality created by minds in some base reality, with physics and processing power beyond our comprehension? What if space itself, with its vast distances and hostile environments, is merely a programmed parameter, a variable set by the simulators for reasons we can only guess at? This simulation hypothesis, popularized by philosopher Nick Bostrom, suggests that advanced civilizations would likely create many simulated realities, and statistically, we're more likely to be in one of the many simulations than in the single base reality. It finds support in the strange fine-tuning of physical constants that permit complexity, in the quantized nature of energy that resembles the discrete states of digital computation, in the apparent informational character of fundamental physics. If we inhabit a simulation, the impossible challenge of living beyond Earth takes on yet another dimension. The barriers we face might not be natural features of reality, but intentional constraints imposed by the simulation designers, programmed parameters that keep us confined to our small corner of the computed cosmos. But this perspective also offers a strange hope. If reality is computed, then the computation might have exploitable patterns, regularities, shortcuts, perhaps even bugs or backdoors that could allow for capabilities beyond what the apparent physics of our universe permits. The simulation hypothesis doesn't solve the impossible challenge, but transforms it, from overcoming natural barriers to discovering the computational structure of reality itself. Imagine reality as the most sophisticated video game imaginable, with physics so consistent and complex that its inhabitants never suspect their world is computed rather than fundamental. In such a reality, the future of cosmic expansion might depend not on brute force engineering within the simulation's rules, but on discovering the underlying code, the deeper logic that determines what is possible and impossible within the computed world we experience as real. The simulation perspective raises profound questions about meaning and purpose in a potentially computed cosmos. Are we simply entertainment for advanced beings? Are we an ancestor simulation created to understand the evolutionary development of consciousness and technology? Are we an experiment to see how minds respond to specific cosmic conditions? Or might we ourselves be proto-simulators, creating virtual realities that will eventually become as sophisticated as the one we potentially inhabit? These possibilities collapse the distinction between real and virtual expansion beyond Earth. If our reality is computed, then all our experiences, whether on Earth or in space habitats or on other planets, are fundamentally information patterns in the simulation substrate. The impossible challenge becomes not how to physically survive in space, but how to recognize and potentially interact with the computational nature of reality itself. As supernovae explode in distant galaxies, as black holes swallow stars and emit gravitational waves, as the cosmic web of dark matter shapes the large-scale structure of the universe, yet another possibility emerges, one that fundamentally reshapes our understanding of consciousness and its relationship to the physical world. What if consciousness is not generated by the brain, but is a fundamental feature of the universe itself, as primary as space, time, and matter? What if awareness isn't the end product of a complex physical system, but an intrinsic aspect of reality that becomes localized and structured through physical systems like the human brain. This perspective, known variously as panpsychism, cosmopsychism, or non-dual idealism, has been proposed by philosophers and scientists from Baruch Spinoza to David Chalmers, from ancient Buddhist traditions to modern integrated information theory. It offers a potential resolution to the hard problem of consciousness, the mystery of how subjective experience emerges from physical processes in the brain. Instead of trying to derive consciousness from matter, it suggests that consciousness and matter might be two aspects of the same underlying reality. If consciousness is fundamental rather than emergent, if awareness pervades the cosmos rather than being confined to biological brains, then the impossible challenge of living beyond Earth transforms yet again. The barrier would not be how to transport conscious beings across hostile space, but how to recognize and access the consciousness already present throughout the cosmos. How to shift from our localized perspective to a more distributed awareness, not limited to our biological form. This view suggests that the future of cosmic expansion might involve not the physical transportation of Earth organisms, but the development of technologies, practices, or evolutionary adaptations that allow human consciousness to recognize its deeper connection to cosmic consciousness, to experience directly what mystical traditions have claimed for millennia: that separation is an illusion, that awareness extends far beyond the boundaries of the individual organism, that the cosmos itself is not other than consciousness. Such a transformation would not eliminate the physical challenges of space travel, but would fundamentally change our approach to them. Instead of seeing ourselves as isolated consciousness in a dead universe, biological entities struggling against a hostile cosmos, we might recognize ourselves as temporary localizations of a field of awareness that permeates reality itself, as participants in rather than observers of cosmic consciousness. The glimpses of such possibilities already exist in human experience, in the profound shifts in perspective reported by astronauts experiencing the overview effect, in the boundary-dissolving states achieved through deep meditation or psychedelic experiences, in the spontaneous moments of connection with something larger than the individual self that humans have reported throughout history. What if these experiences aren't aberrations or hallucinations, but glimpses of a more fundamental reality, one in which consciousness isn't confined to brains, but extends throughout the cosmos? What if they represent the first tentative steps toward a form of cosmic expansion very different from the physical colonization we typically envision? This perspective doesn't nullify the scientific and engineering challenges we've explored. Radiation still damages DNA. Vacuum still boils blood. Microgravity still weakens bones. Psychological isolation still strains mental health. These remain very real challenges for biological organisms evolved on Earth, but it suggests that focusing exclusively on these physical barriers might miss the deeper potential of cosmic expansion, the extension of consciousness beyond its evolved limitations rather than the extension of bodies beyond their evolved environments. Watch as galaxies collide in slow motion across eons, their spiral arms interlacing like lovers embracing across a cosmic dance floor. Observe as stellar nurseries ignite with the birth of new suns, nuclear fusion blooming like flowers in the cosmic garden. Witness the death throes of massive stars as they explode in supernovae, scattering the elements of life across interstellar space, carbon, oxygen, nitrogen, the fundamental building blocks of biology forged in stellar furnaces and distributed through cosmic cataclysm. These processes occur across timescales that mock human lifespans. Millions, billions of years compressed into seconds in our imagination. They span distances that render our planetary home microscopic in comparison. Trillions upon trillions of miles. Gulfs so vast that light itself takes millions of years to cross them. They operate at energy scales that make our most advanced. Technologies seem like stone tools, forces capable of shredding atoms, warping space-time, creating and destroying matter itself. Yet paradoxically, you comprehend these processes. Your consciousness, housed in a 3-pound organ, evolved to help primates find food and avoid predators on the African savanna, somehow grasps the concept of galactic collisions, stellar evolution, cosmic expansion. Your mind, shaped by evolutionary pressures focused entirely on immediate survival in a specific terrestrial niche, nevertheless contemplates events occurring over billions of years and across billions of light years. This paradox itself hints at something profound about consciousness and its relationship to the cosmos. How could a mind evolved for hunting and gathering on one small planet develop the capacity to understand quantum physics, general relativity, cosmic evolution? How could a brain shaped by the need to navigate social relationships in small tribes comprehend the large-scale structure of the universe? Unless, perhaps, consciousness isn't merely a local phenomenon, not just an adaptation for terrestrial survival, but a fundamental aspect of reality that, when structured through sufficiently complex systems like the human brain, can access domains of understanding far beyond its evolutionary origins. This perspective suggests that the impossible challenge of living beyond Earth isn't primarily technological, but perceptual, not about overcoming physical barriers, but about recognizing and strengthening consciousness's innate connection to the cosmos it contemplates. The challenge becomes not how to transport human bodies across hostile space, but how to access more directly the awareness that already permeates the cosmos. How to experience ourselves not as isolated entities in an alien universe, but as expressions of a consciousness that is native to every corner of existence. What if the physics that makes space travel so challenging, the cosmic speed limit, the vast distances, the hostile radiation environment, represents not absolute barriers, but perceptual limitations? What if these apparent obstacles are features of reality, as perceived from our particular evolutionary vantage point, rather than fundamental restrictions on consciousness itself? The impossible challenge would then transform from engineering problem to cognitive evolution, from developing technologies to transport bodies across space to developing the capacity to experience reality beyond the perceptual constraints imposed by our evolutionary history. This doesn't mean abandoning technological approaches to space exploration. Rockets, space habitats, life support systems, these remain essential for extending biological human presence beyond Earth. But it suggests that these approaches alone, constrained as they are by the physics of our three-dimensional perception, may never overcome the fundamental barriers to large-scale cosmic expansion. The true breakthrough might come not from engineering matter, but from understanding consciousness, not from manipulating physical reality as we perceive it, but from recognizing how our perception itself shapes and constrains what we experience as reality. Recent developments in the physics of consciousness hint at this possibility. Integrated information theory proposes that consciousness corresponds to a system's capacity to integrate information across its components, to create a unified experience from diverse inputs. Extended to cosmic scales, this theory suggests that the universe itself might possess integrated information, might constitute a vast conscious system of which human awareness is a localized expression. If so, then the path to cosmic expansion might involve technologies, practices, or evolutionary developments that allow human consciousness to recognize and strengthen its connection to this larger field of awareness, to experience directly what our current scientific vocabulary struggles to express, that the cosmos is not separate from, but intrinsic to consciousness itself. This wouldn't eliminate the need for traditional space technology, but would complement it with approaches aimed at expanding the reach of awareness beyond its current biological limitations. The future of cosmic expansion might involve both physical transport systems for biological humans and consciousness-expanding technologies that allow experience to transcend the constraints of physical location. Imagine neural interfaces that allow direct perception of cosmic phenomena, consciousness, amplifying technologies that facilitate awareness beyond the individual organism, practices that strengthen recognition of the non-local aspects of mind already suggested by quantum physics. These approaches wouldn't replace traditional space exploration, but would open additional dimensions of cosmic experience not limited by the physics of three-dimensional transport. As remarkable as this possibility seems, it finds support in the curious relationship between consciousness and quantum physics. The measurement problem in quantum mechanics, the question of how quantum possibilities collapse into definite outcomes when observed, has led some physicists to suggest that consciousness plays a role in the fundamental nature of reality. That observation itself participates in determining what becomes real from the cloud of quantum possibilities. If consciousness indeed interacts with reality at this fundamental level, then our current understanding of the physical barriers to cosmic expansion might be incomplete. The physics that makes interstellar travel so challenging might apply to unconscious matter, but might operate differently for conscious systems that have evolved to recognize and utilize quantum effects. This perspective doesn't promise easy solutions to the impossible challenge. It doesn't suggest we can simply wish ourselves to other stars or think our way past radiation hazards. But it does open the possibility that the true path to cosmic expansion lies not exclusively through manipulating matter according to our current understanding of physics, but through developing more sophisticated relationships between consciousness and the physical world, relationships that might access aspects of reality currently hidden from our evolved perception. Now, as we approach the culmination of our journey through the impossible challenge of living beyond Earth, the threads we've explored, scientific, philosophical, existential, converge toward a shocking possibility. A perspective so radical, it transforms our entire understanding of the cosmic drama. What if the direction of expansion is wrong? What if the true frontier isn't outward into physical space, but inward into consciousness itself? Consider this. Physical space, with its vast distances and hostile environments, presents seemingly insurmountable barriers to biological expansion beyond Earth. But consciousness has no inherent size, no necessary location, no physical extension that requires transport across three-dimensional distances. What we experience as awareness appears to be located in our bodies, but this spatial localization might be a feature of our perceptual systems rather than an intrinsic property of consciousness itself. Quantum entanglement already demonstrates that physical reality isn't as spatially separated as it appears. Entangled particles maintain instantaneous correlations regardless of distance, suggesting deeper connections underlying the apparently separate objects we perceive in three-dimensional space. What if consciousness operates on principles more akin to quantum entanglement than to classical transportation? Principles that transcend rather than traverse spatial separation. This perspective suggests that the true frontier of expansion lies not in physically transporting consciousness-bearing organisms across space, but in recognizing and strengthening the non-local aspects of consciousness itself, aspects that might already connect us to the cosmos in ways our spatially oriented perception doesn't readily recognize. The technologies, practices, and evolutionary developments that strengthen these connections might constitute a form of cosmic expansion more profound than physical colonization. An expansion that extends not the reach of human bodies, but the domain of human experience, that allows consciousness to access aspects of cosmic reality beyond the constraints of its current biological packaging. This wouldn't eliminate the value of traditional space exploration. Physical presence in space. Human bodies on the Moon, Mars, orbital habitats, eventually perhaps other star systems, remains an essential aspect of humanity's cosmic journey. But it suggests that this physical expansion represents only one dimension of a multidimensional process, that the full realization of humanity's cosmic potential involves the evolution of consciousness alongside the development of space technology. Perhaps this explains the cosmic silence that has puzzled scientists for decades. The absence of detectable signals from other technological civilizations despite the age and size of the universe. Perhaps advanced consciousness doesn't broadcast its presence through radio waves or massive engineering projects visible to telescopes. Perhaps it evolves toward forms of awareness that relate to the cosmos in ways we can't yet recognize, that express themselves through aspects of reality our current perception doesn't access. The impossible challenge of living beyond Earth might be impossible only because we're conceptualizing it primarily in terms of physical transport rather than conscious evolution. Because we're focusing on moving bodies through space rather than expanding the reach of awareness beyond its current perceptual constraints. This perspective transforms the entire framework of space colonization. The challenge becomes not just surviving in hostile environments or crossing vast distances, but evolving consciousness itself. Developing forms of awareness not limited by the biological constraints that currently make space so challenging for human habitation. And this brings us to the most profound possibility of all, one that reshapes not just the future of cosmic expansion, but our understanding of why consciousness exists in the first place. What if consciousness emerges in the BBB universe not randomly, but purposefully? Not as an accidental byproduct of complex neural systems, but as a fundamental aspect of cosmic evolution. What if awareness represents the universe becoming conscious of itself? Matter organized into systems complex enough to contemplate their own existence and the larger reality that produced them. If so, then the evolution of consciousness isn't peripheral to cosmic processes, but central to them. Not a side effect of biological complexity, but an essential expression of the universe's inherent potential for self-awareness. And the expansion of consciousness beyond Earth would represent not an arbitrary human ambition, but the continuation of a cosmic process as fundamental as stellar formation or galactic evolution. This perspective finds support in the curious fine-tuning of physical constants that permit complex life, the precise values of fundamental forces and particle properties that allow for stable atoms, for chemistry, for biology, for neural systems capable of supporting consciousness. If these values were slightly different, complexity itself would be impossible, and the universe would consist solely of simple particles without the capacity for self-awareness. The anthropic principle suggests multiple possible explanations. For this fine-tuning, perhaps we exist in one of countless universes with different physical constants, and we naturally find ourselves in one compatible with our existence. Perhaps the laws of physics necessarily produce the constants we observe, through processes we don't yet understand. Perhaps there's some deeper principle that requires consciousness as part of cosmic evolution. This last possibility transforms the impossible challenge yet again. If consciousness represents the universe becoming aware of itself, then the difficulties of space colonization take on new meaning, not as arbitrary obstacles, but as evolutionary pressures driving the development of more sophisticated forms of awareness. of more direct relationships between consciousness and the cosmic processes it contemplates. The harshness of space, the vastness of cosmic distances, the challenges of surviving beyond Earth, these might function not as absolute barriers, but as selectors for new forms of consciousness, new relationships between awareness and physical reality, new modes of cosmic participation not limited by the biological constraints of Earth-evolved organisms. The future of humanity in space might involve not just engineering adaptations to hostile environments, but consciousness adaptations that transform our relationship to those environments. Developments that allow awareness to experience the cosmos more directly, less constrained by the perceptual limitations of organisms evolved for one specific planetary niche. This doesn't mean abandoning our biological heritage or transcending our humanity in some post-biological rapture. It means recognizing that what makes us human isn't solely our physical form, but our capacity for awareness, for meaning-making, for experiencing reality, capacities that might express themselves through multiple forms as we extend our presence beyond Earth. If the universe is infinite, then somewhere out there, another version of you is watching this video right now, a being with your exact genetic makeup, your exact memories, your exact thoughts at this very moment. Not just similar, but identical in every respect, experiencing precisely what you're experiencing, thinking exactly what you're thinking, feeling exactly what you're feeling. In an infinite universe with finite possible arrangements of matter, everything that can happen must happen, not just once, but an infinite number of times. This means infinite copies of Earth, of human civilization, of you, some identical to our reality, others differing in ways both subtle and profound. What does personal identity mean in such a cosmos? What does individual choice signify if every possible choice is being made by some version of you somewhere in the infinite expanse? What does cosmic expansion represent if human presence already extends infinitely through parallel configurations of matter across endless space? These questions have no easy answers, but they highlight the profound challenge that cosmic reality poses not just to our technology, but to our very conception of ourselves, to our understanding of what it means to be human in a universe whose true nature extends far beyond our evolved intuitions. As we conclude our exploration of the impossible challenge of living beyond Earth, we're left not with solutions, but with ever-deepening mysteries, not with certainties, but with possibilities that challenge our most fundamental assumptions about reality and our place within it. The cosmos we perceive, that vast arena of stars and galaxies, of empty space and hostile environments, might be merely the surface of a much deeper reality accessible to consciousness evolving beyond its current limitations. The barriers we face in expanding beyond Earth might be not just technological challenges, but invitations to develop more sophisticated relationships between awareness and the physical world. Relationships that might access aspects of reality currently hidden from our evolved perception. The impossible challenge thus becomes not a problem to be solved within our current conceptual framework, but an evolutionary pressure driving the development of new frameworks, new understandings of consciousness, of physical reality, of the relationship between the two. It becomes not an obstacle to human ambition, but a doorway to human transformation, to modes of existence and experience currently beyond our imagination. As you contemplate these possibilities, as you grapple with the vertigo-inducing implications of cosmic reality, remember that the very fact of your contemplation constitutes a profound mystery. The mystery of how a collection of atoms on one small planet became complex enough to contemplate its own existence, organized enough to probe the deepest secrets of the cosmos, conscious enough to wonder about its place in the universe. This capacity for awareness, for understanding, for meaning-making, this is humanity's true gift to the cosmos. It may be that our physical expansion beyond Earth remains limited by the harsh realities of space, constrained by the biological fragility of Earth-evolved organisms, challenged by the vast gulfs between worlds. But our conscious participation in cosmic reality, our capacity to experience, to comprehend, to find meaning in the universe, this may extend far beyond the reach of our physical form. The final resolution of the impossible challenge might come not through overcoming physical barriers, but through recognizing that consciousness itself represents a form of cosmic expansion, that awareness constitutes not just the means of understanding the universe, but an essential expression of the universe's inherent potential. In this light, every moment of genuine understanding, every instance of authentic wonder, every experience of connection with cosmic reality represents not just a subjective mental state, but a fulfillment of consciousness's cosmic purpose, a realization of awareness that transcends the boundaries of the individual organism, that participates directly in the universe's evolution toward greater self-knowledge. We've journeyed together through the impossible challenge of living beyond Earth, through scientific paradoxes and existential questions, through biological limitations and cosmic mysteries, through the shocking possibilities that transform our understanding of reality itself. But this journey isn't complete. It can never be complete. For in confronting the cosmos, we confront the ultimate unfinished story. A narrative without end, a question without final answer, a mystery that deepens with each discovery. The universe doesn't yield its secrets easily. It reveals itself in between layers, each understanding giving way to deeper questions, each answer spawning more profound mysteries. This is not a failure of human knowledge, but its greatest triumph, the recognition that reality extends beyond our current comprehension, that the frontier of understanding always lies just ahead, beckoning us forward. What we've explored together isn't merely academic. It isn't abstract theory separate from human experience. It strikes at the heart of what it means to be conscious, in a cosmos whose true nature remains tantalizingly beyond our grasp. It challenges not just our technology, but our identity, not just our capabilities, but our purpose. The impossible challenge of living beyond Earth ultimately reveals itself as a mirror, reflecting our deepest assumptions, our most cherished beliefs, our fundamental conception of what it means to be human. In facing this challenge, we face ourselves, our limitations and potentials, our fears and aspirations, our place in a universe both intimately connected to our existence and vastly indifferent to it. Consider what we know with certainty. The cosmos is larger, older, stranger than human intuition can comfortably grasp. The conditions that permit our existence are remarkably specific, yet seemingly arbitrary from the perspective of physical law. Consciousness somehow arises from matter, organized in particular ways, yet the relationship between awareness and physical reality remains scientifically enigmatic. The universe appears simultaneously hostile to and generative of the complex structures that support life and mind. These apparent contradictions don't represent failures of understanding, but invitations to deeper insight, clues that our current conceptual frameworks, while tremendously successful at certain scales and in certain domains, remain incomplete when confronting the fundamental nature of reality and our place within it. The path forward isn't abandoning what we know, but recognizing its provisional nature, its status as a step in an ongoing journey rather than a final destination. It means holding our most successful theories not as absolute truths, but as useful approximations, as maps that guide exploration while remaining open to revision as new territories are discovered. This scientific humility this recognition that our current understanding, however sophisticated, represents a single frame in an evolving picture, doesn't diminish human achievement, but elevates it. It transforms science from a body of fixed knowledge into a living process, a continuous conversation between human minds and cosmic reality, a relationship that grows more intimate with each question asked and answered. The same humility applies to our visions of cosmic expansion. The futures we've imagined, Mars colonies, orbital habitats, interstellar arcs, aren't predictions but possibilities. Not destinations but directions, not endpoints but waypoints in humanity's cosmic journey. They represent not what will be, but what might be, depending on choices we haven't yet made, technologies we haven't yet developed, understandings we haven't yet achieved. This provisional quality of our cosmic aspirations doesn't make them less valuable, but more so. It transforms space exploration from a predetermined program to an open-ended adventure, from a script to be followed to a story we continue to write with each mission launched, each discovery made, each perspective gained through our expanding presence beyond Earth. Let's revisit the most profound contradiction we've encountered. The universe appears simultaneously made for us and against us. The precise physical constants that allow for atoms, chemistry, planets, and ultimately life seem eerily fine-tuned, as if the cosmos were designed with beings like us in mind. Yet, the environments beyond Earth are lethally hostile, as if the universe were determined to confine life to isolated planetary oases in the vast cosmic desert. This contradiction has no easy resolution, but it does have profound implications. It suggests that our relationship with the cosmos isn't simple but complex, not merely supportive or merely antagonistic, but dialectical, a continuous interaction between entities that both shape and are shaped by each other. The universe has produced us through its physical processes, yet we now produce new understandings of the universe through our conscious observation. We are simultaneously products of cosmic evolution and participants in its ongoing unfolding. This reciprocal relationship transforms the impossible challenge yet again. Living beyond Earth becomes not just an engineering problem to be solved, but a relationship to be developed. A new chapter in the ongoing dialogue between consciousness and cosmos, between awareness and the reality it contemplates. It suggests that our expansion beyond Earth represents not just a physical extension of human presence, but an evolution in this fundamental relationship, perhaps toward forms of mutual influence we can currently only dimly imagine. What might such an evolution entail? Perhaps technologies that interact more directly with the fundamental properties of space-time, not by brute force opposition, but through deeper understanding of how reality responds to conscious interaction. Perhaps biological adaptations that allow human organisms to exist in environments currently hostile to Earth-evolved life, not by imposing Earth conditions on alien worlds, but by developing new forms of embodiment suited to those worlds. Perhaps consciousness developments that extend awareness beyond its current perceptual limitations, accessing aspects of reality currently hidden from our evolved senses. These possibilities aren't guaranteed, but neither are they forbidden by what we currently know. They represent not what will happen, but what might happen if humanity continues to pursue its cosmic potential. If we maintain both the scientific rigor that grounds our understanding and the imaginative vision that extends it beyond current horizons. This balanced approach, neither abandoning empirical reality for flights of speculation nor constraining possibility to current technological capabilities, represents humanity at its best, simultaneously grounded and aspirational, practical and visionary, engaged with what is while reaching toward what might be. The impossible challenge thus reveals itself as neither trivially solvable nor absolutely insurmountable, but conditionally navigable, addressable not through blind optimism or resigned pessimism, but through sustained engagement, through continuous development of both our technical capabilities and our conceptual frameworks, through evolution of both our physical tools and our conscious awareness. This perspective transforms the timeline of cosmic expansion from years or decades to centuries or millennia, from the immediacy of current space programs to the long arc of human development, from the urgency of individual lifespans to the patience of civilizational evolution. It suggests that living beyond Earth isn't a challenge to be overcome in a single technological leap, but a process to be engaged across generations, each contributing to a journey whose ultimate destination remains open, whose path continues to evolve with each step taken. Such a multi-generational perspective might seem discouraging to those who dream of personally witnessing humanity's expansion throughout the solar system or beyond. But it offers a different kind of participation, not as individual beneficiaries of cosmic colonization, but as contributors to a process larger than any single human life, as participants in a story that extends beyond individual experience to encompass the broader arc of conscious evolution. This participation takes many forms. Scientists advancing our understanding of cosmic environments contribute as surely as engineers developing space technologies. Artists imagining possible futures contribute as surely as astronauts physically venturing beyond Earth. Philosophers exploring the implications of cosmic expansion contribute as surely as industrialists, developing the economic infrastructure to support it. Each plays a role in humanity's gradual extension beyond its planetary cradle. Each participates in the ongoing conversation between consciousness and cosmos. And this brings us to the most profound aspect of the impossible challenge: its status. Not as an external problem to be solved, but as an evolutionary pressure shaping human development itself. The difficulties of surviving beyond Earth, the radiation, the vacuum, the psychological isolation, the vast distances, aren't merely obstacles to our expansion, but selectors for new human capabilities, new technological approaches, new forms of social organization, new understandings of what it means to be conscious in a cosmos whose full nature extends beyond our current grasp. Evolution has always operated this way, not by predetermining specific adaptations, but by establishing environmental conditions that favor certain developments over others, that make some pathways more viable than alternatives. The cosmic environment, with its unique challenges and opportunities, now joins terrestrial environments in shaping human evolution, not primarily through biological mutation and natural selection, which operate too slowly for current human timescales, but through technological development, social adaptation, and conceptual innovation. This evolutionary perspective transforms the impossible challenge from a problem requiring a specific solution to a context driving ongoing adaptation, from a barrier to be overcome to a pressure shaping human potential in ways we can influence but not fully predict or control. It suggests that humanity's cosmic future will emerge not from a predetermined plan, but from the complex interplay between our conscious choices and the selective pressures of cosmic environments, a co-evolutionary process between human capabilities and cosmic realities. This uncertainty about specific outcomes doesn't diminish the significance of current efforts toward space exploration and development. It transforms them from steps toward a fixed destination to experiments in an open-ended process, from means to a predetermined end to expressions of an evolving relationship between humanity and cosmos. Each mission becomes not just a technical accomplishment, but an evolutionary probe, testing the viability of specific approaches, generating information that shapes subsequent developments, contributing to the gradual extension of conscious presence beyond Earth. The history of life on Earth demonstrates the power of such evolutionary processes, from single-celled organisms to complex multicellular life, from aquatic creatures to terrestrial ones, from reptiles to mammals, from primates to humans. Each transition represented not a predetermined outcome, but an adaptation to specific environmental conditions, a viable pathway among many possibilities. Yet collectively, these adaptations produced consciousness capable of contemplating its own origins, technology capable of extending beyond its planet of origin, awareness capable of comprehending the cosmos that produced it. The future of life beyond Earth may follow similar patterns, not a linear progression toward a predefined goal, but a branching exploration of multiple possibilities, some viable and others not, some leading to novel forms of conscious embodiment and others to dead ends, some expanding human potential in currently unimaginable ways, and others reinforcing current limitations. The precise outcomes can't be predicted, but the process itself, the gradual extension of conscious presence beyond Earth through ongoing adaptation to cosmic conditions, can be engaged, sustained, and consciously directed toward expanding, rather than limiting possibility. This evolutionary framing transforms the impossible challenge from a test to be passed or failed to a context within which humanity continues to develop, from a problem with a binary solution to a relationship with ongoing significance. It suggests that the question isn't whether humans can live beyond Earth in our current form, but how humanity itself will transform as it expands into cosmic environments. Not whether we can overcome unchangeable cosmic realities, but how we'll adapt to and potentially reshape those realities through our technological capabilities and conscious understanding. The apparent impossibility of the challenge thus reveals itself as a feature rather than a bug, not an absolute barrier to expansion, but a selector for approaches sophisticated enough to navigate cosmic complexities, not a final verdict on human potential, but an invitation to develop beyond current limitations. The cosmos doesn't yield easily to human presence precisely because such yielding would require no significant evolution beyond our current capabilities, would demand nothing new from consciousness, would catalyze no expansion of human potential. This perspective transforms the timescale of cosmic expansion from the urgency of immediate colonization to the patience of sustained development, from the expectation of quick solutions to the recognition of ongoing engagement. It suggests that living beyond Earth isn't a challenge to be solved once and for all, but a relationship to be continually developed, not a destination to be reached, but a direction to be followed, not an answer to be discovered, but a question to be lived. And this brings us to perhaps the most profound aspect of the impossible challenge, its status as an invitation to conscious evolution, to the development of awareness beyond its current perceptual limitations, beyond its current conceptual frameworks, beyond its current relationship with physical reality. The cosmos doesn't just challenge our technology, but our consciousness itself. Not just our ability to engineer environments suitable for our current form, but our capacity to evolve forms suitable for cosmic environments. This evolution has already begun in small ways. The development of scientific understanding represents an extension of consciousness beyond its intuitive limitations, a capacity to comprehend aspects of reality not directly accessible to our evolved senses. The creation of technologies that detect radiation, that visualize electromagnetic frequencies outside the visible spectrum, that register gravitational waves or subatomic particles. These extend consciousness beyond its biological constraints, allowing awareness of cosmic phenomena our unaided senses cannot perceive. But these developments represent just the beginning of a potentially much deeper evolution, one that might eventually allow consciousness to recognize and access aspects of reality currently hidden from both our evolved senses and our technological extensions. The strange connections suggested by quantum entanglement, the curious relationship between consciousness and physical reality implied by the measurement problem, the possibility of dimensions beyond the three spatial and one temporal dimension we directly experience, these hint at a cosmos richer, deeper, more intimately connected than our current perception reveals. If consciousness can evolve to access these deeper aspects of reality, through technological interfaces, through biological adaptations, through conceptual frameworks that transcend current limitations, then the impossible challenge of living beyond Earth might be navigable in ways we can currently neither predict nor fully imagine. The barriers that appear insurmountable from our current perspective might become navigable from a more evolved vantage point, not through violation of physical law, but through deeper understanding of reality's true nature. This possibility doesn't guarantee easy solutions or quick achievements. It doesn't promise magical technologies that instantly overcome the harshness of space or the vastness of cosmic distances. But it does suggest that the true frontier of cosmic expansion lies not just in engineering innovation, but in consciousness evolution. Not just in developing more sophisticated rockets or life support systems, but in developing more sophisticated relationships between awareness and the reality it contemplates. The impossible challenge thus becomes a driver of not just technological, but conscious evolution, a context pushing awareness to transcend its current limitations, to develop beyond its evolutionary packaging, to explore aspects of reality currently hidden from our perception. It becomes not just a test of human engineering, but an invitation to human transformation, to modes of existence and experience currently beyond our imagination, but potentially accessible through sustained development of both our technological capabilities and our conscious awareness. This evolutionary perspective transforms the significance of current space exploration efforts. Each mission becomes not just a technical achievement, but a step in the gradual extension of conscious presence beyond Earth. An experiment in human adaptation to cosmic conditions, a probe into the relationship between awareness and environments, fundamentally different from those that shaped its evolution. The International Space Station, the planned lunar bases, the potential Mars missions, these represent not just engineering accomplishments, but consciousness laboratories, contexts in which humanity begins to explore how awareness adapts to non-terrestrial environments. The data gathered from these missions isn't just technical, but existential. Not just information about engineering challenges, but insights into how human awareness responds to cosmic contexts, how consciousness adapted to terrestrial conditions functions when those conditions change radically. Each astronaut returns not just with technical knowledge, but with transformed perspective, with direct experience of Earth seen from space, of living in microgravity, of existing in environments not shaped by evolutionary pressures, but created through conscious design. This experiential data, this first-hand knowledge of consciousness operating beyond its planet of origin, may prove as valuable for humanity's cosmic future as any technical accomplishment in rocketry or life support systems. It represents the beginning of a feedback loop between cosmic environments and human awareness, a circuit through which consciousness begins to adapt to conditions fundamentally different from those that shaped its terrestrial evolution. This adaptation has barely begun. The weeks or months spent by astronauts in orbit represent a tiny fraction of a human lifespan, a microscopic moment in evolutionary timescales. Yet even these brief exposures produce significant changes in human physiology, in neural function, in psychological perspective. What transformations await those who might spend years on Mars, decades in orbital habitats, entire lifetimes in environments beyond Earth? What consciousness developments might emerge through sustained exposure to cosmic rather than terrestrial conditions? These questions have no predetermined answers. The evolution of consciousness in cosmic environments will emerge through the complex interplay between our adaptive capabilities and the selective pressures of those environments. 8th dance between human potential and cosmic reality, whose outcomes we can influence but not fully control or predict. What we can do is maintain openness to possibility, a willingness to recognize and nurture promising developments, to explore multiple pathways rather than committing prematurely to single approaches, to allow for emergence of capabilities currently beyond our imagination. This evolutionary framing transforms the impossible challenge from a problem requiring a specific solution to a context driving ongoing development, from a barrier to be overcome to a pressure shaping human potential in ways we can engage but not fully determine. It suggests that humanity's cosmic future will emerge not from a predetermined plan, but from the complex interaction between our conscious choices and the selective pressures of cosmic environments. A co-evolutionary process whose specific outcomes remain open, but whose direction we can influence through our current decisions. Those decisions aren't just technological, but philosophical. Not just choices about engineering approaches, but about values, priorities, and definitions of success. Will we define successful cosmic expansion primarily in terms of physical presence, measuring achievement by the number of humans living beyond Earth, or primarily in terms of conscious extension, valuing the development of awareness that transcends current limitations even if physical presence remains limited? Will we prioritize quick achievements visible within individual lifespans, or sustainable developments that might take generations to mature? Will we focus on replicating terrestrial conditions in space, or on developing new forms of embodiment adapted to cosmic environments? These choices aren't mutually exclusive, but they do involve trade-offs, resource allocations, and directional emphasis that shape the evolutionary pathways available to future generations. They represent not just practical decisions, but philosophical ones, not just how we'll address the impossible challenge, but what we believe that challenge ultimately means for humanity's cosmic potential. This philosophical dimension transforms space exploration from a merely technical endeavor to a profoundly humanistic one. From an engineering problem to be solved to a context for exploring what it means to be human. From a challenge to our capabilities to a question about our identity. The cosmos doesn't just test our technology, but our self-definition, our understanding of what aspects of humanity are essential and what aspects are contingent on our specific evolutionary history. What we must preserve as we expand beyond Earth and what we might necessarily transform. These questions have no simple answers, no resolutions that can be determined once and for all. They represent ongoing conversations that will evolve with our expanding presence beyond Earth, with our developing understanding of cosmic reality, with our transforming awareness of what consciousness can become when freed from some of its terrestrial constraints. They are not problems to be solved, but inquiries to be lived. Not barriers to progress, but invitations to deeper engagement with the mystery of conscious existence in a cosmos whose true nature remains tantalizingly beyond our full comprehension. And this brings us to the most profound aspect of the impossible challenge. Its status not as a final verdict on human potential, but as an open question. A question that can be engaged but never fully answered. A mystery that deepens rather than resolves with increased understanding. A horizon that recedes as we approach, yet continues to beckon us forward. This mysterious quality doesn't represent a failure of human comprehension, but a feature of reality itself. Not a limitation we must overcome, but a richness we continue to explore, not an obstacle to cosmic expansion, but the very territory into which we expand. The cosmos doesn't yield final answers because it isn't a puzzle to be solved, but a reality to be experienced. Not a challenge to be mastered, but a relationship to be developed. Not a test of human capability, but a context for human becoming. The impossible challenge thus reveals itself as neither impossible nor possible in any final sense. Neither an absolute barrier nor a trivial hurdle. Neither predetermined failure nor guaranteed success. It reveals itself as an open-ended engagement between consciousness and cosmos, between awareness and the reality that both produces and is perceived by it, between beings evolved on one small planet and the vast universe that somehow generated conditions permitting their existence. This engagement has barely begun. Humanity's tentative steps beyond Earth, our orbital platforms, our lunar landings, our robotic explorers on Mars and beyond, represent the merest beginning of what might become a sustained expansion of conscious presence throughout our solar system and potentially beyond. The questions raised by the impossible challenge, technological, biological, psychological, philosophical, remain largely unaddressed, their answers to be discovered not through abstract speculation, but through direct engagement with cosmic reality. This engagement invites your participation, not just as passive spectators of space missions conducted by others, but as active contributors to humanity's cosmic future. This participation takes many forms, supporting space research and development through educational and political engagement, pursuing careers in sciences, technologies, and arts relevant to cosmic expansion, developing philosophical frameworks that grapple seriously with the implications of consciousness extending beyond its planet of origin, creating cultural expressions that inspire continued engagement with the cosmic frontier. But perhaps most fundamentally, participation means maintaining openness to the questions raised by the impossible challenge, resisting both facile optimism that trivializes the difficulties and resigned pessimism that forecloses possibility, engaging seriously with the technological, biological, psychological, and philosophical dimensions of cosmic expansion without prematurely committing to specific outcomes or approaches. It means recognizing that the impossible challenge isn't one to be individually solved, but collectively engaged. Not a personal accomplishment, but a civilizational process, not a goal to be reached within a single lifetime, but a direction to be sustained across generations. It means finding meaning not in witnessing the final resolution of these questions, but in contributing to their ongoing exploration, in playing a role, however modest, in humanity's gradual extension beyond its planetary cradle. This multi-generational perspective doesn't diminish the significance of current efforts, but transforms it, from steps toward a predetermined destination to experiments in an open-ended process, from means to a fixed end to expressions of an evolving relationship between humanity and cosmos. It allows us to value both the practical accomplishments of current space programs and the philosophical questions they raise, both the technical challenges they address and the existential insights they generate. As you consider these questions, as you engage with the technological, biological, psychological, and philosophical dimensions of the impossible challenge, remember that your consciousness itself represents a profound cosmic mystery. The very fact that collections of atoms on one small planet became complex enough to contemplate their own existence, organized enough to probe the deepest secrets of the cosmos, aware enough to wonder about their place in the universe. This remains perhaps the most astonishing aspect of cosmic evolution. This capacity for awareness, for understanding, for meaning-making, this is humanity's true gift to the cosmos. It may be that our physical expansion beyond Earth remains limited by the harsh realities of space, constrained by the biological fragility of Earth-evolved organisms, challenged by the vast gulfs between worlds, but our conscious participation in cosmic reality, our capacity to experience, to comprehend, to find meaning in the universe, this may extend far beyond the reach of our physical form. The final resolution of the impossible challenge might come not through overcoming physical barriers, but through recognizing that consciousness itself represents a form of cosmic expansion, that awareness constitutes not just the means of understanding the universe, but an essential expression of the universe's inherent potential. In this light, every moment of genuine understanding, every instance of authentic wonder, every experience of connection with cosmic reality represents not just a subjective mental state, but a fulfillment of consciousness's cosmic purpose, a realization of awareness that transcends the boundaries of the individual organism, that participates directly in the universe's evolution toward greater self-knowledge. This perspective doesn't eliminate the value of physical expansion beyond Earth, of human bodies on the Moon, Mars, orbital habitats, eventually perhaps other star systems. It suggests that this physical presence represents one dimension of a multidimensional process, that the full realization of humanity's cosmic potential involves the evolution of consciousness alongside the development of space technology, though expansion of awareness alongside the extension of biological presence. The impossible challenge thus becomes not just a technological problem, but an invitation to a deeper engagement with cosmic reality. Not just a question of engineering, but of evolving consciousness, not just a matter of survival, but of expanded experience. Not just a challenge to be overcome, but a mystery to be lived. As you contemplate the cosmos tonight, as you gaze at the stars scattered across the darkness, at the planets tracing their orbits, at the galaxies too distant to be seen with unaided eyes yet present in your awareness through scientific understanding, remember that the universe isn't separate from, but intrinsic to your existence. The carbon in your cells, the oxygen you breathe, the metals in your blood, all were forged in stellar furnaces billions of years ago, scattered through space by supernova explosions, eventually incorporated into the Earth and ultimately into your body. You are, in the most literal sense, made of stardust, not metaphorically, but atomically, not poetically, but physically. The cosmos isn't something out there, separate from your existence, but something in here, constitutive of your very being. The impossible challenge of living beyond Earth thus becomes not just about extending human presence into space, but about recognizing the cosmic nature of human existence itself, about consciousness that emerged from cosmic processes, experiencing more directly the reality from which it arose. This recognition doesn't solve the technological, biological, psychological, and philosophical challenges of cosmic expansion, but it does transform their significance, from problems external to humanity to questions intrinsic to our nature, from barriers between us and the cosmos to pathways deeper into its mystery, from obstacles to be overcome to invitations to be engaged. The cosmos calls to you not as alien territory to be conquered, but as estranged origin to be remembered, not as hostile environment to be tamed, but as vaster home to be recognized, not as lifeless void to be colonized, but as reality already intrinsic to your existence, physically through the stellar origin of your atoms, consciously through your capacity to comprehend cosmic processes, existentially through your participation in the universe's evolution toward greater self-awareness. This calling doesn't guarantee success in addressing the impossible challenge. It doesn't promise technological breakthroughs or biological adaptations that would make cosmic expansion easy or inevitable. But it does suggest that the challenge itself represents not an arbitrary human ambition, but a natural extension of consciousness's cosmic evolution. Not a departure from our nature, but a deeper realization of it. Not an abandonment of our origins, but a return to them on a higher level of awareness and understanding. As we conclude this exploration of the impossible challenge, one final question remains, perhaps the most profound of all. What if the universe itself is alive? Not in the anthropomorphic sense of having human-like thoughts or emotions, but in the deeper sense of being a vast, integrated system with purposes we cannot fathom, potentials we cannot predict, awareness different from, but perhaps not wholly unlike, our own? What if expansion beyond Earth represents not human conquest of passive territory, but conscious engagement with a reality that somehow responds to our presence, that shapes our development even as we shape small portions of it, that participates in an evolving relationship with the awareness it has generated through cosmic processes? This possibility transforms the impossible challenge yet again, from a one-sided technological problem to a two-sided evolutionary relationship, from something we do to the cosmos to something we do with it, from unilateral expansion to mutual engagement. It suggests that the future of humanity beyond Earth will emerge not just from our conscious choices, but from the interplay between those choices and the larger cosmic context that both enables and constrains them. A dance between human aspiration and cosmic reality whose specific steps we can influence, but whose overall choreography transcends our individual direction. This dance continues, with or without your conscious participation, with or without your awareness of its significance. The cosmos that produced you continues its evolution. The awareness it generated through processes too complex for complete comprehension continues to explore its own nature and the reality that gave rise to it. The relationship between consciousness and cosmos continues to develop in ways we can engage but not fully control or predict. The impossible challenge remains open, neither definitively possible nor impossible, neither guaranteed success nor predetermined failure, but an ongoing question lived through technological development, biological adaptation, psychological evolution, and philosophical inquiry. It remains not a problem to be solved once and for all, but a mystery to be engaged across generations, not a destination to be reached, but a direction to be followed, not an answer to be discovered, but a question to be lived. And perhaps this open quality, this resistance to final resolution, represents not a limitation, but the challenge's greatest gift. Not a frustration to be overcome, but an invitation to continued engagement. Not a barrier to achievement, but a driver of ongoing evolution. Perhaps the cosmos remains mysterious, precisely because mystery itself represents not absence of understanding, but presence of infinite possibility. Not a void to be filled, but a richness to be continually explored. Not a problem requiring solution, but a reality inviting ever deeper participation. As you return to your daily concerns, as the cosmic questions raised by the impossible challenge recede from immediate awareness, as the practical challenges of terrestrial existence demand your attention, remember that the mystery continues unfolding. The cosmos that produced you persists in its evolution. The awareness it generated through processes too vast for complete comprehension continues to explore its own nature and the reality that gave rise to it. The relationship between consciousness and cosmos continues to develop whether or not individual humans recognize their participation in this larger process. But conscious recognition transforms the nature of this participation, from unconscious involvement to intentional engagement, from passive presence to active contribution, from being merely shaped by cosmic processes to participating in their direction. The impossible challenge invites precisely this transformation. This shift from unconscious product of cosmic evolution to conscious participant in its ongoing unfolding. This development from awareness confined to its evolutionary origins to awareness that recognizes and realizes its cosmic potential. This invitation remains open to you personally, to humanity collectively, to consciousness itself as it continues to evolve through biological, technological, and potentially post-biological forms. The impossible challenge awaits not definitive resolution, but continued engagement. Not final achievement, but ongoing evolution. Not ultimate answers, but ever deeper questions. The universe isn't static, but dynamic. Not fixed, but flowing. Not predetermined, but emergent. Its mysteries don't represent barriers to human understanding, but territories for conscious exploration. Not problems requiring solution, but realities inviting ever deeper participation. The cosmos has no end. But maybe consciousness doesn't either. The impossible challenge continues. Will you join the dance?